Hello and welcome to the second day of NDC Oslo. I hope everyone had a wonderful first day. And while I can't be with you all in person today, I'm really looking forward to sharing the next hour with you. And this will be where we'll look to solve a question facing many API developers, and that is how do we choose between GraphQL, gRPC, and REST? So to get to the answer to that question, we're going to do quite a number of things. So we're going to start off by looking to gain a common understanding of the API styles that have evolved over time. We'll then look at software architecture and look at system properties and the constraints or decisions that then define or yield those properties. With that base knowledge, we're then going to look at a number of conversations that are happening in the API industry today and see if we can apply this learning or this logic to some of the statements that lack some nuance or some constructive element. And then finally, we're going to bring this all together and look at some sample scenarios that you may face to make it more concrete should you choose to use one of these API technologies when you either have a personal project or bring it back to your office. So before we proceed, a little bit about myself. So my name is Rob Crowley. I am the head of engineering for a company called VIX, and we build automated fare collection systems. So similar to the Oyster card in London, or we work with Router in Oslo as well. Before that, I was a consultant for a number of years, including Telstra Purple or Redify in Australia. And the vast amount of my career has been in building and designing distributed systems. So APIs are a subject that are very close to my heart. I'm also the co-organizer of DDD Perth, Western Australia's largest conference. And last year we had over 800 attendees. So that's really been a massive success. And I'm also available on the socials at Rob D. Crowley. And this is a talk that I've been giving various versions of for about a year now. And the genesis was really some of the challenges that I was not only personally facing, but also my clients and the companies that I worked with. And while that might sound rather altruistic, there was a slightly selfish element to it as well. And that was really a reflection that my Twitter timeline was really an absolute tire fire. And you might ask, why is that? Well, when I first joined Twitter, it was really about the same time that I started to get into APIs in a serious way. And REST was the on vogue API style at the time. So I started following many of the luminaries in the industry, such as Mike Amundsen or Eric Wild. And I learned a huge amount from these people, and it was wonderful about 3 to 4 years. And then 2015 came around, and Facebook released GraphQL. And I started following a whole host of new people. And the problem was, these two groups of people didn't often agree. So one tweet could then yield 15 or 16 rebuttals or counter-arguments. But many of these counter-arguments were very black and white. X is better than Y, or Y breaks this. I found it very difficult to then take that information or take that statement and then apply it to the problems that I was facing. So I'll share a small example of what I saw there. So back in 2019, on May 25th, actually my birthday, I saw this tweet and it was like, it's 2019, you should learn GraphQL. This was very much the same time I was playing around with quite a lot of the real-time subscriptions elements of GraphQL. I said, absolutely, this is something that we should have available to us. So I agreed with him quickly. Aaron, he is one of my good friends, but one of the cloud advocates at Microsoft. It's just fancy OData. And that again is while it's a playful exchange, we do see more serious versions of that going around. And I would like to comment that actually this weekend, Aaron will be building an app with GraphQL. So I think in the long run, I might well have won that argument. But it's not just happening on Twitter. So if we look at some of the blog posts that have been shared, as I say, sort of Back in 2017, so a couple of years after GraphQL got released, and there was really a sense there that it would completely eclipse REST. And this particular article says REST is the new SOAP. In other words, we won't need it anymore. It's dead, defunct. And again, I found this quite confronting because I had spent the last 10 years of my career learning REST APIs and learning how to build effective, how to design resources and workflows. Is all this learning now defunct, not required? And this isn't an isolated article either. Another one from about the same time declared REST APIs are rest in peace. Long live GraphQL. Again, more sentiment from the community that there was only one way to build APIs moving forward. And I personally didn't see that that was the case. And I saw many of the clients I were working with had the same problems or were facing the same challenges. And it wasn't just these conversations. I had this sense of deja vu when I read a lot of these articles. And I couldn't help but feel that we've actually been here before. So if that's what was happening in 2017, let's wind the clock back a little bit further and we'll go back to 2010. And in this case, we could see the same sort of articles, but this time declaring REST being in the ascendancy and SOAP again going out of favor. And this one that says SOAP is officially dead, long live REST. And the unfortunate truth is a huge number or percentage of the APIs we deal with today in production, they're still SOAP-based. While it mightn't be on vogue to build new APIs using that today if we have other choices, it is definitely not dead, and many of us are still supporting APIs in many different technologies. But what can we really take away from this? So if SOAP is dead and REST is the new SOAP, does that mean GraphQL is the new REST? Surely not. That couldn't be the case. It wouldn't make any sense. But lo and behold, yes, it is apparently. GraphQL is indeed the new REST. Part one. I'm not sure if there was ever a part two, but if there is, please let me know. So what can we actually learn from these exchanges? The first thing that we would have seen is that they're all very black and white. They all have one view and don't really take in a lot of possibility for an alternative. So maybe we can dismiss all of this and simply say, maybe we just don't like XML and we get on with it and we look at different challenges. But to do that, I feel, would miss a very important point. And that is that many of our API consumers, the very people we build APIs for, and again, something that's close to my heart is we build APIs for other developers. So many developers are unsatisfied and frustrated with the APIs experiences that they're experiencing or receiving. And also our API community is very small. We need to work together, so we can't really afford to have these camps with different ideologies or different views around certain technologies. So what I'm really hoping from today's talk is that I can give you the necessary foundation of understanding that you will be able to take a balanced approach to choosing the API's technologies and styles for the problems at hand. And maybe that sounds a tiny bit idealistic, maybe a tiny bit of a dreamer. So we could imagine that there's no protocols. It's not hard to do. Maybe there's no hypermedia hills to die on, no media types. We don't have to worry about contracts. Wouldn't that be wonderful? Unfortunately not. That's not how APIs work. APIs are required to allow two parties that are otherwise distributed to communicate effectively. We will never get away from having to have shared semantics and also shared syntax. So we cannot just understand what's meant by the message, but also how to decode and encode that message. So we have to have standards and protocols. So this is the problem that we need to face into. So let's see a little bit about how these technologies or styles have evolved over time. So I'll take us all back to 1991, and we'll start with Corba, so a middleware language. And at the point in time, this was really seen to be the future of e-commerce on the web. Unfortunately, for some, it actually fell out of favor for XML of all things. Moving forward to 1993, we had remote data access. So a client-server approach where a client could then query data from a remote database. So it sounds very like a query syntax, and it was. And we'll see some similarities in that approach as we see some future API styles and technologies. So moving forward into 1998, we had a formal specification of XML RPC, and RPC stands for Remote Procedure Call, and it is a term coined by Bruce Nelson. But up until this point, RPC was an approach, but there wasn't a specification around it. So in 1998, we had a formal specification for doing RPC over XML. In 1999, Don Box and four others from Microsoft, and the name Don Box might be familiar as the man behind the four tenets of SOA, and they released SOAP. So again, a heavily RPC-based technology, which then used a WSDL as the contract that would then format the exchange between the client and the server. In the year 2000, Roy Fielding released his seminal dissertation about REST, and this was really about building APIs that didn't work orthogonal or against the web, but really embraced it. So how can we build APIs that are sympathetic and embrace the underlying protocol? And this is mainly for the purposes of the APIs we'll be talking about today, HTTP. Moving forward to 2005, and in this period, REST really begins to rise to the ascendancy in the APIs that we're building. And we still have RPC, but at this time, we've seen XML give way to JSON. And that's really keeping in sync with what we saw with the move to REST as well. Moving forward to 2007, we had OData, another technology released by Microsoft under the moniker of a better way to REST. And this really embraced a lot of the ideas of remote data access, where it provides a rich query syntax for the client to define exactly the data that it needs from the server. So instead of a uniform interface constraint, which defines a canonical URL for each resource and in which we will then receive a representation back from the server, this then provides a huge amount of data to the client to define exactly what it wants in the shape. So moving forward from 2007 to 2015, GraphQL lands on the scene. And again, this is really about empowering clients to receive only the data that it wants and avoid some of the perceived inefficiencies around REST. And then in 2016, we've got the latest incarnation of gRPC. And that is, again, RPC going back all the ways we saw back in Corba in 1991. And while the approach remained consistent, we've seen the implementation of the technologies change over time. So if that's the technologies themselves, what can we see that has been happening in parallel within the industry? So in the early 2000s, we were really building APIs for specific partners, and they were stovepipe integration. So one-to-one, one client going to one server, and it's a discrete integration. This really changed with Web 2.0 starting in about 2010, when companies like Twitter and Facebook start building public APIs. And these are APIs where one server can support multiple different clients. But instead of it being built for one specific client, it's more of a conformist API, if you are aware of Eric Evans and domain-driven design, where they don't take into account individual client needs, but rather define an interface which we all conform to. And this has really been the prevalent style for public APIs for the last decade. And then where are we going to see happening next? So there's quite a lot of people in the industry saying that the next wave will likely be autonomous APIs. So rich lattices of APIs that will then be composed to achieve higher order business needs. And this will be underpinned by technologies like serverless as well, which reduces the footprint and will move to a more worth-based model for APIs. But this is still some ways off, and the majority of us will still be in the second wave of generic APIs, particularly if we're building public-facing APIs or APIs for multiple internal teams within your organization. So across all of these technologies, while they might appear relatively different on the face of it, they all share a surprising number of commonalities. So we have flat file APIs. So an example of this might be electronic data interchange. And while it might sound antiquated, it is a perfectly valid and in fact ideal choice if you were doing large batch operations. For instance, maybe month-end reporting, and instead of sending a paper-based file between two companies, you can do that electronically to a defined format. And if that's a batch style APIs, the complete antithesis of that is a streaming API where we're constantly exchanging data between the client and the server. And that could be stock price changes, or it could be video or data streaming. We have RPC APIs. So most recently brought to the fore again by gRPC, where with an RPC API, we are effectively treating the distributed call almost as if the network was not there. So we're treating it at a higher order, and we're trying to keep the semantics of that higher order language as well. With a web API, how we call and consume data is very different. So instead of using classes that abstract away the network, we actually spin up a HTTP client. We embrace the web. We send HTTP methods to define, again, what operations we would want, again, to a specific URL. So we're really embracing the web with that. And that's the major change or difference between the experience of calling and consuming an RPC or a web API. And I'll ignore the semantic or design changes for this particular point in the talk. And it might be a challenging message to hear first thing on the second day of NDC Oslo, but there is no single best API style. Computing is hard. Building APIs is challenging. What I can say, though, is there is absolutely a best API style for your problem. And that is really the purpose of today's talk, to arm you with the information required that you can first define or identify the appropriate style, and then the technology for your own problem at hand. So how might we go about being able to inform ourselves about this decision? And we can take some guidance from Roy Fielding. He said that the properties are induced by the set of constraints within an architecture. So in other words, the design choices that we make will then yield certain characteristics of the solution. And when we think of constraints, we often just think of technology constraints, but there's many types that we really need to consider to build an effective product. There's business constraints. So anything that really affects the profitability of a company or business endeavor. So that could be time, could be financial budget, and this could be across your customer, your own business, or certain product requirements. Maybe you're just looking to have a very perishable window of opportunity, and that's a severe set of maybe time constraints on what you can build. Then there's technical constraints. So embracing all the challenges of distributed computing. So we have the 8 fallacies. So the network is not reliable, latency is not zero. So what are all the things we need to do to support maybe the security concerns or delay that we're facing, but also how we need to be able to evolve the system over time. And the final and probably the most interesting set of constraints is all around the operation of that service. And this is really all the socio-technical or the human constraints around. So how are we going to support or build this system? Is there multiple teams within an organization building it? In which case then looking at Conway's law, which states that the systems we build will be a mirror of the communication pattern between our teams. So these are things that have become very close to my heart in my current role, where I'm looking to align the operating model again with the product lines that we're looking to build. And it's not just about organizing teams, but it's also about the set of knowledge or expertise within your teams. So for instance, REST, to build an effective REST API, requires deep expertise in HTTP. And if you don't have it, you will struggle to be able to get the most out of that API style. So again, really looking at all of the elements around your teams, how they're organizing the knowledge they have to drive some of these decisions as well. And so when we take all of those constraints, be they business, technical, or socio-technical, they will then yield the properties of the system. And that will be the properties of the software system itself, but also the wider ecosystem, everything around the operation of that product. And when I'm designing a system, I always start with the properties. I define the characteristics that the system needs to have, or the properties it needs to display. And then I work backwards to say, what constraints or decisions can I make that will then yield those properties? So it's always a case of defining what you need and then working back. It's definitely not a case of starting with a technology and hoping it will fit your problem. So how might we gain some insight into being able to do this in practice? And again, Roy Fielding has some interesting guidance for us in this case. He says that while there's never an optimal architecture style for every application, we can start comparing architectural styles by the properties induced. And this was really the original premise for this talk. And I was slightly dismayed to learn 5 minutes into my research for it, is that someone else has actually done it. So Zenacademic gave this talk, or a very similar detailed review of REST and GraphQL in the end of 2018 at Nordic APIs conference. And he goes into quite a lot of detail about the pros and cons of different API styles, particularly in terms of REST, which I would say he started with and then started to compare GraphQL with. It is a very insightful talk. I'll include a link to it in the references that I'll share at the end. But it doesn't cover gRPC. So over the course of the next talk, we'll weave in some of the insights that Denick had, but then also update where we've sort of seen over the last 16 months, 18 months since he gave that talk as well. So instead, we're going to look at something that's a little bit more fun. So we're going to look at some of the conversations that have been happening in the API industry over the last sort of year and a bit. And then we're going to, for each of those statements, we're going to take the next level of detail to it and then start dispelling some of those myths, and at the same time using these as the vehicles for comparing different aspects of these API styles and showing where some shine and where others don't. So let's tackle the initial ones that I mentioned at the start of this talk. And that is the statement that REST in peace APIs, that REST APIs are REST in peace APIs and long live GraphQL. Or as another person put it, GraphQL will do to REST what JSON did to XML. But they're blanket statements and they don't let us know why or any context of supporting that statement. So let's start by looking at some of the thinking that underpins these API styles. So GraphQL on the read side, so where the client is querying data from the server, looks very like RDA, so remote data access. It affords a huge amount of power to the client to request the data and only the data it needs. However, on the right side, it uses RPC, and that's for the mutations. So that's again a write, or subscriptions, which are an event-based way of getting real-time data in GraphQL. So we can see actually that GraphQL heavily builds on the API styles and previous approaches. And in fact, it's also got a fair amount of HTTP semantics woven into it as well. So let's compare GraphQL then to gRPC. And gRPC is quite different. GraphQL and REST are both protocol agnostic, whereas gRPC is firmly tied to HTTP2. Not HTTP 1.x, but specifically HTTP2 to support multiplexing across a single connection. And this is really where gRPC is focusing on, is about performance. So again, being able to have very performant real-time interactions across different distributed components. And if HTTP2 is the protocol, gRPC then uses protobuf or protocol buffers for both the contract, the interface definition language. So in the case of SOAP, this was WSDL, or in the case of a GraphQL API, that is the GraphQL schema. And in REST, it could be an Open API Initiative contract or RAML or API blueprints. So it uses protocol buffers for both the contract, but also as the data exchange format across the wire. So how we encode and decode data. And REST is something very different again. So if gRPC and GraphQL are data over HTTP, REST is really a state machine over HTTP. And when I say state machine, what I really mean is workflow. So it could be a business process, which based on what stage in the process you are, you could have multiple different actions or paths that you can take. And state machines then are driven by an aspect of the uniform interface constraint, which is hypermedia. And hypermedia is often one of the things that we struggle to understand in a REST API or how we can build those affordances into our responses. But it's actually a concept that many of us are already familiar with. So if we take a look at this very basic web page, what we can see is there's actually a number of hypermedia controls already. We have an image tag, an anchor tag, and a form. And all of these controls have well-defined semantics, which then allow any browser to consume this page and know what to do with the data. So an image tag, when the browser receives that, it will dereference the resource that is mentioned at that URL, and it will then display that within the allocated space in the window. When you click on an anchor tag, that link will be dereferenced and you will be navigated to that particular page. And with a form, when you submit that form, all the data will then be packaged up and sent to the server. I talk a lot about hypermedia because I do feel it is absolutely foundational to building a REST API. And while we often see it at the top of the maturity model at level 3, for me, it's either REST or it's not, and that is defined by whether it is HTTPS or not. So hypermedia is the end of an application state. I don't mean this to be a confronting message. I apologize if it is. But I firmly believe that where we don't embrace hypermedia, we end up with a lot of REST-ish APIs that are difficult to consume, but also require a fair amount of knowledge to build. And I firmly believe that in many cases, those APIs would be able to be built more effectively or deliver a better experience, maybe using one of those other styles, if again, from a socio-technical constraint, we don't have the the knowledge to be able to get the most out of that style. So really, don't build REST-ish APIs. There are many options that we have available and the many different constraints that will then be able to yield the best outcome for our consumers, which is really the goal in any API that we build. And while that as I mentioned, might be a tiny bit confronting, I hope it's not, because there is no best API style. So if your API is mostly actions, then RPC is actually a brilliant choice for us. But we shouldn't start saying, I want to build a gRPC API. So a great example of a public RPC API would be the Slack API, for instance. However, if an API is mostly CRUD or manipulating related data, maybe with a workflow, then REST is a fantastic choice. And Phil Sturgeon, the person who I've quoted here, writes a blog, APIs You Won't Hate, and he has a wealth of knowledge to share on this subject, so I would encourage you to follow him as well. And even one of the authors of GraphQL, Lee Byron, stated that GraphQL is not the optimal choice for all scenarios. It is very much focused on client-server, where the clients or multiple clients have very different data requirements. For server-to-server communications, there are better choices. That's where gRPC shines, or Thrift from Twitter, and even REST APIs in simpler cases as well. So again, understand the context in which you're in. So wrapping up, API styles address different problem spaces. In some cases, REST-ish APIs, which I feel have been responsible for a large amount of the backlash against REST APIs, would actually be better built in other styles. Not because those other styles are inherently better, but some require less of a ramp-up time on behalf of the development team. And gRPC is a perfect choice for synchronous communications between internal services. So where your domain requires very frequent data updates and potentially different interactions rather than the client-server call that you might see with a REST API, but supporting other scenarios such as streaming data from the server, where one call from the client can result in multiple responses from the server, or vice versa, where client streaming, or in many cases, bidirectional streaming. So again, different styles and different technologies support the different areas of your application. So moving on to another comment that was coming up quite a lot in sort of at the start of last year. It's died down a little bit, but there was this view that GraphQL breaks caching. And the first question we should really think about is, what type of caching? Because there's many. Does it just universally break it? I'm not too sure. So there's client side. So that might be in the browser, or in the case of GraphQL, in the denormalized client cache. There's on the server side, also known as application caching, or intermediary caching proxies such as Squid, Varnish, or Nginx. So let's take a look at this in a HTTP context. So in addition to client and server side, you can have intermediaries, which will then be able to hold that data between the clients and the server, reducing latency. And while we can do that for HTTP, that's not an option for GraphQL or gRPC. So while you can still handle data on the client and on the server, the intermediate options are not there. And that's really about how they use HTTP across the wire. So posts, for instance, which are typically used by GraphQL, are not cacheable by default, not by the intermediate proxies. And why could that be an issue? Because while the speed of light is very fast, about 300,000 kilometers per second, it's not infinitely so. So typically, if you can get your data closer to the client, they will get it faster. And where there's a will, there's a way. The GraphQL community have looked at options about how to support intermediary proxies. And they've taken a look to be able to use the get HTTP method along with persisted queries. And persisted queries was really championed by Apollo, one of the vendors or producers in this area, particularly in the node space. And that is, instead of the client sending all the data to the server, the entire query, rather this query is stored on the server, and then just a query ID is sent across, and then that query is hydrated on the server before being executed. And with that, we can get back to using a HTTP GET method. But there's not a standard around here, which is a shame, because that was really what simplified a lot of GraphQL development. Instead of REST, which was an architectural style, and a lot of the implementation was left to the development teams, hence the large ramp-up time that I spoke about previously, GraphQL eliminated a lot of that by providing a concrete specification to work from. But there is no GraphQL specification for operating over HTTP. There are a few unofficial ones, but nothing that can really bind the community together. But it's not just about intermediary proxies. There's also other aspects to consider. Authenticated traffic, so for instance, any traffic with the authorization header that might contain a API key or a bearer token, will not be stored by default by shared caches. And if this is a case where all of your data is personalized or tied to a specific identity, this changes your problem domain quite a bit. So maybe you wouldn't have used intermediary proxies at all. So again, consider that in your domain, that whether the traffic is anonymous or whether it's always served to a specific client. There's also other aspects, such as the more customizable you make an API, in other words, the more power you give to the client to define the data that it needs, the less cacheable it will become. So in REST, when you have /customers/5, that is very cacheable because there's nothing else you can do with it. The second you make it more flexible, you are reducing the likelihood of a cache hit. So wrapping up, there's many different kinds: client, server, and intermediary network. Be aware which ones are powerful in your context. Highly customizable APIs benefit less from intermediary proxies. And if they are valuable, then REST is a brilliant choice. And best practices are still emerging for GraphQL and gRPC. Another comment which I found quite amazing was the view that REST APIs are inefficient. And what do we really mean by inefficient? Because in many cases, REST was never about short-term efficiency. Rather, it was about longevity, long-term evolvability, and evolution of a client and a server, which aren't tightly coupled together. So I think in many cases, when we say inefficient, what we actually meant was performant, so that there was performance issues. And typically, this was the result of overfetching or underfetching. So overfetching is where we would retrieve far more data than we required, potentially wasting expensive data plans, or underfetching, where we had to make multiple calls to the server to retrieve the data that we need. And yet we have techniques for this as well. So we can use sparse field sets to address overfetching, or compound documents, such as defined in JSON API or HAL, Hypermedia Application Language, in those media types to be able to type multiple responses together or representations in a single envelope. And this is really where GraphQL was first positioned. And that was being able to allow any client to retrieve exactly the data it needs in a single round trip to the server. However, there's an implication to this, is that the slowest field now dictates the overall response time. And this has always been the case with any API. But with GraphQL, giving all that power to the client to build up arbitrary depth queries, we are compounding that effect quite a bit. So in fact, all the data might come back in a single call, but the time the client needs to wait for all that data to respond can actually be quite high. And when I first started getting GraphQL APIs into production, that performance tuning of queries became a significant overhead to my teams. And again, there's been certain movements in the industry to try to overcome this. So using deferred queries, where parts of the data will be sent back to the client initially, and then HTTP patches for subsequent parts. But it all adds complexity. And what we really should be asking ourselves now is, should it be this complicated? Should it really be this hard? And HTTP2 has really been a big game changer in this area. With HTTP 1.x, we use many hacks to try to overcome some of the cost of a connection. So be that the TLS handshake or the TCP handshake or window scaling needed, but we ended up with typically very poor connection reuse, and then the high cost of a handshake quite often in our APIs. Whereas with HTTP2, we can have long-lived connections and all of those communications between the client and the server happening over a single multiplex connection, removing a lot of that cost or waste in doing multiple calls. So in fact, looking at compound documents and in fact, being able to pull back all that data in GraphQL in a single call is very much a double-edged sword. If we could make separate calls that didn't have a performance impact, then that's actually a far better outcome for us, because we still get all of the caching semantics we would want from the discrete calls, but not the performance hit of making multiple calls. So it's a win-win. There's other aspects to HTTP2 as well, such as server push. And frameworks or open source projects such as Vulkan actually embrace server push to be able to then have the server proactively push additional representations to the client, even without the client asking for it. So again, being able to, if you retrieve the master, automatically push the child resources to the client, because the chances are they will need it. So that's quite a powerful approach. And while it never really gained traction in the web space, because prefetch links with directives were generally easier to work with, it's showing a lot of promise in the API space. So performance. In HTTP 1.x, the cost of a handshake was very high. And that is both at the TCP level, but also at the TLS level. And HTTP removes the need for compound documents by actually reducing or avoiding the multiple handshakes that would have been required in 1.x. And server push creates new possibilities again. There's still certain issues with efficiency and the fact that all of those push representations live within the HTTP2 connection rather than the other caches on the browser. So again, if that connection dies, so does that cached copy. And there's other aspects such as cache digests that will be able to allow the clients to say, don't push these because I already have it. So it's still an emerging technology and approach. And gRPC heavily uses HTTP2 for that multiplex connections for the streaming operations that it supports. But then does HTTP2 make GraphQL irrelevant? So again, if GraphQL was all about compound documents, supposedly, do we need it anymore? And again, GraphQL is not just about network efficiency. And I feel we'll see as a community this starting to become less and less important as we move forward. But the value of a technology is actually the sum of its parts. So again, as I mentioned before, all the other constraints, it's not just about the technology, it's about the ecosystem and the tool. And GraphQL offers an incredible developer experience. You can get very good documentation out of the box using generation. And it also comes with a wonderful SDK. So again, how actually people consume it. And if you look at an example for this, in V3 of its API, GitHub had to support multiple client libraries or SDKs for many different languages. With the power of a GraphQL specification, with V4, it didn't have to do that at all, because the community could build GraphQL client libraries or SDKs that would then support its API without having to do that work themselves. It also allows developers to use that tooling of choice to deliver an excellent developer experience. So when we're choosing a technology, think about all of the facets of the ecosystem around it. So again, the true value of GraphQL and many technologies lies in the tooling ecosystem and not just the immediate technology itself. If you're only concerned then with network efficiency, then a HTTP2 endpoint might be a great choice for that, because compound documents are no are no longer the only option we have for improving network throughput, but this story is far from finished. Another one of my favorites is GraphQL supposedly eliminates the need for versioning. However, there was never a need to version your API. It is a strategy for decoupling a client from a breaking change in your API. It is a strategy for compatibility, not a requirement. And it's not the only option we have available either. So we have versioning as being one, but we also have graceful evolution. And when Roy Fielding was asked, how should you version a REST API? The simple answer was, don't. And in fact, this is exactly the same view that the GraphQL designers took as well, favoring graceful evolution through the deferred attribute or directive. And to my mind, graceful evolution should always be your goal, but it does require discipline. So for instance, we can't add required inputs. We can't make outputs that were required, make them optional. We can't remove them. We can't change the type of a field from a number to a string. And we should always follow the robustness principle of Postel's law. So be incredibly broad with what you accept, but incredibly specific with what you send. And this requires discipline. And I guess the key thing there is don't rely on graceful evolution alone. Not over-communicate with your users around these changes. So it's not enough to say, in my mind, to put a deprecation or a sunset header in your API responses and then have your API consumers update automatically. Send out a bulletin, let them know what will change, engage them, let them know how long the window is that you can support them. Particularly important when you're building APIs for internal teams in your organization, but that still adds a lot to the developer experience of making your API a joy to use. And it's not just on the server side. So clients also need to have discipline. So tolerant reader pattern, as defined by Martin Fowler in the Enterprise Integration Pattern book, is again how clients should respond to APIs. So don't deserialize directly into classes. So if the fields appear in a different order, don't break. If additional fields that you aren't interested in appear in the response, again, don't break. So apply the tolerant reader pattern. And that's what allows both the client and the server to evolve independently or more robustly. And GraphQL makes this an inbuilt feature. So it makes deprecations through the @deprecation directive. And when I first started using GraphQL, I thought this would be incredibly powerful. Instead of doing broadcasts to say, this field might change, who will be interested, who should I engage with? Because I know every field that every user is requesting, I'd be able to have specific conversations. What I found, though, is it doesn't take long until everybody uses something. So you're always dealing with, if you have to introduce a breaking change, really going through the same steps you would have anyway. And it's not just about the contract level. There's also certain inbuilt behaviors in your API about performance, for instance, which, while they're not defined in the contract, there's absolutely other people relying on it, particularly if you've got multiple APIs that you might have daisy chained together, ignoring multiplicative effective downtime. And then latency becomes a big issue across those services because we want to tune the timeouts. So even if we're doing a refactor as well of some of the behavior, in many cases, understanding that you shouldn't really fix or change a behavior, and many of those behaviors cannot be defined in the contract alone. So again, communication with your users becomes incredibly important. So how might we go about being able to create our solutions that can evolve gracefully? And this is really by embracing the interface, which in our APIs needs a contract-first design. So in GraphQL, it's the schema, it's the protocol buffer, or again, the OpenAPI, RAML blueprint, etc. definition. And once we have that shared understanding around the interface, both the client and the server team can work independently using mocked stubs against that interface. Finally, you can integrate, and the whole loop repeats again. So if you're not using a contract-first approach, particularly when you want to be able to build things in parallel, I would encourage you to investigate the approach. It is incredibly powerful to be able to iterate a contract very quickly, rather than having all the code that you need to change. So when you're designing your API, the later you can write the code or the higher fidelity, the better outcome you're likely to have with less friction. So versioning, it's a technique for managing breaking changes, never a requirement. You can do that for any of the API styles that you can support, but again, prefer graceful evolution if possible, but it requires both the client and the server to adopt those robustness patterns. Absolutely not a substitute for communicating with users, and it doesn't protect your users from depending on implicit behavior or non-functional requirements. The final one we'll look at is domain modeling is purely a REST concern. That's absolutely not the case. We have to embrace software architecture design and understand their domains irrespective of the APIs or the styles that we use. And we should always start with your users front and mind and work backwards. So what's the experience we need to provide? And then how might we go about designing that? So again, the contract is a great way to be able to do this rapidly. And while both gRPC and REST start with an outside-in approach, GraphQL changes it a little bit, whereby we build a graph and then which depicts all the data that can be queried, and then the client projects its queries onto a certain portion of that overall graph. So the side effect of this is GraphQL actually allows you to delay the last responsible moment for what the optimal queries are until the users start using the system. So you don't have to iron out exactly what endpoints they will have because they can define the shape of their own data. The trade-off with that is, again, performance tuning gets pushed to the right in the process. So API designs. So API design skills absolutely table stakes irrespective of the style. You have to understand your problem domain. Both REST and gRPC follow an outside-in design, so starting with the experience, define your endpoints, define your operations in the case of gRPC, and then work backwards. And GraphQL delays this moment until profiling queries. So if you have a domain and you don't have a great understanding of potentially multiple clients that need very different data, rather than creating bespoke BFFs or different endpoints for each client, GraphQL allows you to support that in a fairly elegant manner, albeit just at, in my experience, the cost of some of the greater operational overhead of it. So with those conversations understood, let's actually look at some sample scenarios in the final sort of 7 odd minutes that we have together, and look where I would be looking to apply one of these styles. And the tenets I would always have, as I mentioned before, start with the properties and then work backwards to the constraints. And one of those things, always keeping simplicity in mind. So what's the simplest approach that you could take to solve this problem, rather than a technology approach trying to fix the problem? So if you're just building a basic application web form, maybe just a single client, that web page, we use all the data and all we're doing is posting it to the server, there is no value at all in using anything more complicated than just a simple HTTP post. Keep it simple. Don't say, but I might need more functionality in future. That's fine. It's very easy to change it, but keep your landscape as simple as possible. Both you and maybe the person who supports the code base after you will be thankful of that in the long run. Where GraphQL does absolutely shine is at that composite API level. So maybe you have a suite of APIs existing within your company, and maybe there are many different technologies and many different clients requiring different data. And maybe there's multiple round trips to the server and performance is an issue. Very much the same challenge that Facebook were facing when they were creating GraphQL. Then GraphQL does give you a second chance to build the API you wish you had built originally. But it only gives you one chance that can then act as a facade to those downstream services. But it does not absolve you from really understanding what those data needs are. But GraphQL is absolutely agnostic of the underlying data source. It could be another service, it could be a database, it could be files, it could be another web service. But it does provide an incredibly powerful common interface into data, whether that data exists on the client, on the server, you want to interact with it in a real-time or a request-response unary type style. So having that single interface into your data, particularly when you have multiple different types of clients, can be very powerful. Something I've been using quite a bit with my teams as well is the sort of the BFF style for mobile apps. So instead of having many responses going back to the client and having to stitch all that data together, really use a BFF. So backends for front-end pattern to extend the application boundary to the API as well. And gRPC can really shine in this area because what you can then have is a single technology that can support all of the APIs that you have. So you can have incredibly powerful code generation for protocol files defined and then code gen in any number of modern languages. And having a very simple way of then testing consistently across your entire landscape. So we've seen that with certain clients that have then simplified their architectures a lot by being able to choose one style and really optimize their teams for how to build and release those APIs. And again, gRPC is great when you have highly, I would say, temporally coupled APIs, particularly microservices that all need to exchange data in a real-time basis. And gRPC, again, is perfect for that. But there's certain scenarios which we can't support. So for instance, gRPC cannot be used natively in a web browser. We simply do not have access to the low-level frames in a browser that's required for HTTP2. Likewise, we can't support gRPC hosted on ASP.NET App Services. We don't have access to some of the trailing headers that we need. So even though we can support HTTP2, there's certain aspects of that protocol that aren't supported. So again, what the industry have done in this area have come up with a companion protocol, gRPC Web. And that's effectively a way of doing gRPC over HTTP 1.x in a compatible way. But if we're going that from a client, you typically need a proxy that will then convert the HTTP 1.x traffic to 2.0 for your internal services. And typically that would be Envoy, is what I've used before. So the sidecar technology from Istio, which you might be aware from it. But there's also experimental technologies from Microsoft, from James Newton King and co, which allows you to run that on an app service without the need for a separate proxy. So again, as I mentioned, there is an option there, but it is experimental for now rather than a finished product. But I do understand that Microsoft are committed to it. So, takeaways. You would have seen that there's many different API technologies and styles that have evolved over time. While they appear very different initially, they actually come back to a number of core styles, each which support or are aligned to a certain set of problems. We then saw how you can start looking at the properties of your system, then working back to the constraints that would then help deliver those properties or characteristics. From there, with that knowledge, we then started to look at some of the conversations which are happening in the community, and then being able to look at those statements and then apply that constraint and property thinking to understand what's actually important in your domain. And then finally, we looked at just a few real-world scenarios, which hopefully got you thinking that maybe this is similar to something that I've been building myself. That will give you some guidance to be able to understand where you should start your journey when you leave or get back to work from NDC Oslo. So thank you so much for choosing my talk this morning. It's been an absolute pleasure to be able to share some of my experiences with you. If you're looking to download any of the slides, they are available at this URL. Once you download them, you will also gain access to all of the resources that I used in the creation of this talk as well, such that you'll be able to get that next level of detail as well. So thank you so much for your time, and I hope you have a wonderful remainder of NDC Oslo. Thank you.
Hi, and welcome to my session, The 5 Pillars of Collaborative Product Ownership. So my name's John LeDrew, and I've been in the software industry now for about 20 years. And in that time, I have done many different things. Been a software engineer, a team lead, a technical lead, architect, development manager, tester, business analyst, project manager, and for my sins, even a product owner. So at this point, and this is the fun thing of trying to translate things to online talks, I'd normally give all of the product owners in the audience a little gift, specifically some stickers, because everyone loves stickers. Only these stickers say and are labeling the product owners with some of the things that people might have heard the product owners be called. That is that what we have are things like the single ringable neck, the one throat to choke, the one person that gets fired if the project goes wrong. And I have a lot of issues with the language that we use to talk about product owners. Because I don't know, but I reckon most product owners don't really like having the title, the single ringable neck. So what's interesting about that is that particular phrase. I imagine that's one that many of you will be familiar with. And people wonder where these phrases come from. Well, that particular phrase was actually coined by Jeff Sutherland in the book that introduced Scrum, which I find an interesting thing when we think about, he also created the product owner role. So I think there's an interesting question. When I ask the audience at this point and they say, well, what does this actually mean? What does single ringable neck mean? Why might it be valuable potentially? And what you have is a lot of people talking about, well, it's so important to have a single point of accountability. Well, I find that an interesting challenge, really. Why is a single point of accountability really important? Well, is it because we think that people won't step up if there isn't? Do we need one person to be beating everyone with? A common one is that we don't want the engineers to be distracted with all of the questions from the customers. Otherwise, they wouldn't be able to just, get their head down in their dark little room and focus on the things they need to do. So we give that job to the product owner. But then there's this other problem, isn't there? So the product owner is also going to be the central focal point of all the kind of business knowledge, potentially like an SME. But as engineers, I think most organizations have recognized that it's a pretty dangerous thing to have all of your technical knowledge for a key subsystem in one person's head. But apparently that's fine for a product owner. I don't know. To me, this all seems a little bit sketchy. So what makes a great product owner? At this point, I'd love to have a go. I don't know if people are on the Zoom call, but if there are people on the Zoom call, what would be awesome is if people could unmute themselves maybe and shout out just one word to tell me what they think makes a great product owner. If there's no one there, I'll have to fill in. Anyone have any ideas? No? No one know what a good product owner is? All right, that's fine. So words that normally come up here. things that we normally hear. We will hear things like available. This is a really good one. What makes something available? Well, why is availability of a product owner really important? Well, this is what happens. What tends to happen on teams is you're working away as your team, and then suddenly you get stuck because you don't know the answer to some question that you need from the customer. And at that point, you might go to the product owner and say, I don't know, should this look like this or this? Should this button be green or hot pink? And the product owner might be sat with you. It's a common trope of XP and Scrum teams to have it's product owners sitting with the team. And that technically means that availability, that time is zero. Perfect. Or you could have the product owner maybe in the next room. Well, at that point, you're going to have to get up and walk through. Maybe they're not there. Maybe that chat gets a bit more. Well, that availability is a little bit longer. That lead time to getting that answer is a bit longer. And then even worse, maybe that product owner is in the next building. And what's more, they're split between 3 other teams. And maybe the lead time that they can get you that answer is in fact days. Well, what happens to teams then? Well, what happens is that the teams go, okay, well, I was working on A, but I can't finish A now because I don't know whether or not he wants a hot pink button. So I'm just going to start on B. We'll just park that for now. It's fine. It's in a branch. It'll all be okay. Git will help us merge it later. Then we go to B and we start on B. But then obviously product owner is still not back from his holiday. So now I'm stuck again because I have another question. So but that's okay. I can just park that. And then I start on C and that keeps going. And I've seen that many, many times. So the problem is that availability is a core one. The other sides of things that we hear are things like inspirational, being able to be the inspirational leader for the team. Well, I'm not sure about that. I think that can be valuable, but I think that the team can share that inspiration around a little bit more. Okay, so inspirational, available. These are some of the things we hear frequently. We also have other things like being able to be decisive, being able to make all of those decisions, like, is this going to be a blue or a hot pink button? And it's important to be able to do that, to be really kind of clear. An important thing that is tied to being decisive is it's often not just being decisive in many organizations. Actually, what it often is also being empowered, actually having the power to make that decision. So I once worked on a project where there were many, many stakeholders, but all of these stakeholders were in positions of seniority to the product owner on the team. And as a result, what that really meant is that this person, in order to make pretty much any decision on the project whatsoever, had to get sign-off from 20 separate individuals, all of which had strong opinions about what color buttons should be. Then there was the other side of this, which just compounded the problem that each of those 20 individuals was split across 5 time zones, I think, if I remember correctly, which clearly caused a lot of issues on the project. So availability and actually being empowered, the product owner needs to, in fact, own the product, which means they can take independent decisions on the direction of the project in order to be able to move things along. It's all very well that they can be decisive, but actually if they're not empowered and they can't they're not empowered to make those decisions, then all they're really doing is middle management, just forwarding things around. So decisive, available, empowered inspirational. These are all lovely things, but a lot of the time, this seems like a bit of a fantasy. Rarely, when we put all of the attributes of the product owner we would love to have many people actually had the experience of working with that product owner. And that's a sad truth. They seem to be a little hard to find. So let's have a look at the official definition of product owner. This is from the Agile Alliance and was up to date as of a few weeks ago. I don't think it's changed much recently. So the product owner is a role on the product development team responsible for managing the product backlog in order to achieve the desired outcome that a product development team seeks to accomplish. So I really like this definition as it's at a starting point. It's kind of nice. You've got the product owner is a role on the product development team. They don't own the product development team. And they're responsible for managing the product backlog, fine, in order to achieve the desired outcome that a product development team seeks to accomplish. Now, what I like about this is that the product owner is a member on the product development team, but the whole team desires a particular outcome and seeks to achieve that. And the product owner collaboratively with the team is helping the team to accomplish that goal by managing their role in that is to help manage this product backlog. So what I really like about that is that they are seems like a very collaborative position. So what's interesting here is that this particular definition on the Agile Alliance page that I nabbed it from, it has separate bullet points. And these bullet points kind of go to, I think, attempt maybe to clarify the position of product owner. But, well, we'll see what happens here. So the second bullet point is clearly identify and describe the product backlog items in order to build a shared understanding of the problem and solution with the product development team. Well, I've got some issues with this because it seems to me by this definition that the PO is responsible for identifying all the problems and then defining the problems and then solving the problems and then communicating the problem and solution to the team, which I guess at that point, the team, I don't know, go to the pub because the problem is apparently solved. Yeah, I have some issues with that definition for obvious reasons. But seriously, the main problem I have with this definition is the word solution. The problem I have is that we don't build a shared understanding of a solution. We build the solution. The problem isn't solved until it's solved. You don't, and we should avoid using the word solution until it's actually solved. It is not solved if it is currently on a whiteboard, unless the solution is in fact a whiteboard. You know, an architectural plan of how we're going to design the class structure for this particular thing is not the solution. It is just an idea, an experiment, a potential direction. Solution is something that you get to. It isn't something that you start with. So next little bullet point, make decisions regarding the priority of product backlog items in order to deliver the maximum outcome with the minimum output. So I used to think that maximum outcome with minimum output was kind of hilarious and sounded like something that Schwarzenegger would say, maximum outcome. But I think I think that really, as it happened, that particular phrase, maximum outcome, minimum output, well, minimum output is seen, or output is seen in this definition as the work, the amount of effort essentially expended, and outcome being the valuable benefit. What value was delivered in order to get this? So actually, that bit I take less issuance with. But here's the thing: the product owner is going to determine how the priority of things, and this is common. What decisions they're going to make. Oh, well, they're going to make decisions on the priority, i.e. how important is feature A over feature B? Which one should we do first? But how does a product owner make these decisions? Well, when I ask audiences this question, I get a range of answers, but normally they say, well, that the business tells them what to do. The business? What's the business? The business, you mean the whole organization they work for collectively tells them what is important? No, they mean the business, because obviously the business is apparently separate from the technology team that's within the business. I don't know. To me, that doesn't make any sense at all. The business, the organization, you are one organization, most likely. So what they mean, maybe that the customer, well, the customer, I'm talking about an internal team here, clearly, as opposed to an agency customer. But the customer tells them that. So let's say the customer is, I don't know, their manager. Okay, well, how does their manager know what to do? How do they know what is most important? How do they know how to make those decisions? Oh, I don't know. That could be the CEO of the company. They're guided by strategy. The organizational strategy tells them what way to go. Well, how was the strategy come up with? How do we know that's the right strategy? And I can keep trolling. But in reality, this is a really important question, because you know what happens when I keep asking an audience, how do we know? How do you know? How do you know that's the right decision? Eventually, people go, and I can tell you, I imagine, but there is a really dreadful correlation between wind direction and successful organizational strategy. This is not a valid thing. There is no strong correlation here. It doesn't work. Wind direction isn't the ideal option. Neither is flipping a coin or any other form of vaguely random direction selection. The reality is most organizations are not using any form of sane customer directed decision-making process. So what would that mean? Well, we've probably all heard the phrase user experience these days, or UX. Well, UX research, as it's called, is a foundational concept. Well, I gave this talk last year before, to a room full of about 500 people. And in that room, and this is typical when I give this session, I will only expect to see, when I say is user experience the guiding light, is asking the customer what they want, what they think is important, whether or not you solve their problem. What problems do you have? If talking to the customer is that actually your guiding light? Is that your true north for specifying your product direction and strategy? I only see a handful of hands go up. And I think that's pretty common. I can't see all of you. I'm hoping maybe some of you are throwing your hands up, screaming at the screen, saying, we do UX in our company. It's a brilliant idea. I hope that's happening. So determine whether a product backlog item was satisfactorily delivered. Well, what does that mean? What does satisfactorily delivered mean? Delivered to spec? Does it meet the acceptance criteria? What is the definition of success for a project? Well, if you got my vibe from the previous bullet point, well, interesting. Maybe we should ask the customer if the thing that we delivered solves their problem. Maybe we should do that. But again, many organizations don't. This talk is not about user experience, but in reality, these things are naturally entwined, because as a product owner, you are making the decision as to what direction you should take your product in. And if that's not driven by customer need and customer communication, then I have no idea how else you could possibly be driving that. Ensure transparency into the upcoming work of the product development team. Oh, this is a fun one. So I often ask this. I don't really understand this. So previously, we looked at that earlier definition. We identified that by the definition, it says that the product owner is on the team, and the team collectively are going to, they desire to take the product in a particular direction. So they're going to drive the product forward. They're going to decide the goals collaboratively. Well, if ensure transparency into the upcoming work, I'm guessing upcoming work is the backlog, because I'm not sure where else the work would be. Well, if we're going to ensure transparency into the upcoming work, well, surely the backlog and the contents of the backlog was defined and agreed collaboratively with the team. So why would you need to ensure transparency of that? Isn't it already transparent? Isn't it already available? And then I've had this conversation, which goes something along the lines of, product owner, well, I mean, I wouldn't want the team to see everything. I mean, they would just get distracted. Right? Distracted. What do you mean by distracted? Well, I mean, if they could see like 6 months of work, I mean, I've got that in my pipeline. I mean, they're all on my desk in cards. They're all in Jira. All 25,000 of these stories, they're all in Jira. We've got plans for years. But if they could see them, they would just start developing stuff. They would just start just randomly pick something from the bottom of the list. Yeah, because some of that stuff is more fun, maybe. Oh, really? So you think the engineers? I mean, have you ever seen that? Has anyone ever seen that? Ever seen an engineer just randomly start working on something literally at the bottom of the backlog because it seemed like it was more entertaining? Well, I don't know. I've definitely seen engineers prioritize things that might be more challenging or more interesting to work on. But rarely do you ever see massive changes in priority taken by a team member. It happens, but that you've got separate challenges there. This isn't just a symptom of an engineer. Engineers don't just randomly start working on whatever the hell they want, just because it seemed interesting. And then that's the other kind of the other question here is that in reality, whenever I've seen situations with apparent priority problems, oh, why are they working on that? That's not important, those kinds of issues. Well, in reality, those issues, really, most of those problems are, no one has any idea what the priority is anyway. Nobody really knows what's the most important thing, because the most important thing is normally whichever thing the product owner has most recently been shouted at about by their customer or his manager or something else. And that could change by the hour depending on what company you're working in. So how do we know what to do? Or another way of putting it, where does the work come from? And as we were saying before, we really often, in many organizations, are still essentially guessing. We guess as to what's most important. A fun one when they're not using the customer, a fun answer I get when I say, how do we know what to do? How do we know what's most important? Is, oh, we follow our competitors. Well, I like that. I like that idea, because obviously every organization in the world, key, recommended, top up their business strategy is to be just that little bit behind all of your competitors, because that's going to be great. Who needs innovation? We want to be just there. We're happy with that position. Maybe some advantages to that. Who knows? So really, when we are looking at how we know what to do, most of the time, if we're not going to the customer directly and saying what's working, what isn't, what do you need, then we're often not great at knowing what to do. In fact, we're really pretty useless. This is a little taken from a study called Exceeding Value from an organization called the Standish Group, who also make a thing called the Chaos Study that people might have referred to before. The interesting thing here is, if you can see the the chart, what this tells us, and what they were looking at was, I think about 1,000 organizations, and they were looking specifically at software created, kind of internal bespoke software, so custom order management systems and the like. So bespoke software delivered to large organizations. And what they were doing was comparing the original, the features that the engineering teams believed they delivered with the features that the people that use the software every day, you know, the things they use. So they'd say, how are you using this software? Oh, I do this and I do this and I do this. And what features do you not use but are aware of? Essentially, how often do you use those things? And what was interesting was that it's a really, really difficult thing to measure. So we can assume a really high error margin on this data, because it's pretty difficult to measure these things effectively. But even taken with a high error margin, 80% of delivered features hardly ever or infrequently used. That's a pretty stark judgment on the software industry's ability to just know what our customers want without talking to them. So this is all pretty depressing. What can we do to improve this? What can we do? Well, the most important thing is, but I'm not going to tell you yet. We're going to leave you hanging there. And what I'd like to do is jump back to the about a century ago. This guy is a guy called Frederick Winslow Taylor, who many will have heard of. Certainly, if you took did any kind of MBA or anything like that. So this guy is an early 20th century humanitarian. This is a little quote. He's known for the high regard in which he held his workers. The ordinary pig iron handler is not the type of man well suited to shoveling. He is too stupid. There is too much mental strain, too much knack required of a shoveler. All right, so he's not a humanitarian. But he was more. He was a scientist, and he was more than the inspiration for traditional management everywhere. What we tend to forget, or perhaps ignore, is that Taylor was actually one of the first people to really popularize the empirical method in business. So what did Taylor do? Let's have a look. So Taylor was working in a metalworking factory, roughly at the turn of the century. And he wanted to improve efficiency. So he started by breaking down every process into its component parts. So if you imagine a metalworking factory, they're going to be producing whatever, like sheet metal or nuts and bolts, or let's say metal doors for the sake of example. And there's going to be a process like melt the shovel the coal into the pig iron, into the furnace, melt down the pig iron, etc., etc. Okay. And a particular area that he had in his tome of greatness, his books on scientific management, as he called it, he focused a lot on shoveling. So he broke down the process into its component parts. And then what he did was he went around the factory floor and he measured everything to a hundredth of a minute. So how long does it take each of the stations? And obviously they're not just one pig iron shoveler in a factory. There could be a number of them. So he looked at each one and he timed every single one. This is what actually referred to as a time and motion study. So he measured all the different stations across the floor, and worked out what the timing was. But to his horror, there was massive inconsistency across the factory floor. Each of the workers were doing the same jobs, but differently. I mean, would you believe it? They considered themselves to be craftsmen. And for goodness sakes, craftsmen. And each of them had their own approach and style of work that was handed down by their granddad, who used their granddad's ways, who used their dad's ways. And some used different tools. Some used a variation on the process. So you've got Bob over here who likes to shovel the pig iron like just with his arms like this, just like that. And then you've got Mike, who uses the shovel that his mum gave him for Christmas. And then you've got Bob, who kind of uses two trowels and does like a double troweling action. Well, that's great, but there was such variation. So his idea was to identify the one true way for each process, the most efficient, empirically demonstrated, most efficient method, which he would discover and then dictate to the workers and show them the right way to do it. Why would they possibly want to do it the wrong way? So how did he discover the one true way? Well, we've got so what did he know? He looked at what he knew currently. What do we know currently about the thing? Okay, well, we've got Bob doing it that way and Mike doing it that way. Okay, well, he then formed a hypothesis. Okay, that hypothesis might be, maybe if I make a small change, maybe it seems that Mike, with the shovel his mum gave him for Christmas, is better than the others, a bit quicker. So what if they all used that shovel instead? What if they all did it that way? So he then made a small change, and he would insist that the workers do it in that particular way in an experiment. And you go around and time everyone again. And this is him testing that hypothesis. This then demonstrates the validity of that hypothesis, which produces learning, which he learns from. Now, what's interesting is, and really important here, is that sometimes this invalidated his hypothesis. Sometimes it proved that actually he was wrong. They weren't any quicker when using Mike's mum's shovel. But either way, there was learning. And this new information is fed back to make more hypotheses. And the cycle continues. And this is a thing known as continuous learning. This created an environment of continuous learning, which is a catchphrase for the modern world. But interestingly, in Taylor's situation, this led to drastically increased efficiency because there was this continuous cycle of improvement. We talk about things like continuous improvement, and these are phrases, again, modern catchphrases, but this started here. Now, on the other hand, he also triggered a whole number of workers' strikes, the more experienced workers feeling that they lost their individual style and expression, which he was obviously suppressing. This environment of continuous learning that he'd created was limited to the upper echelons of the organization. The only people, in Taylor's view, with, I quote, the mental capacity for this planning work. But then again, he did see dramatically increased efficiency. So what was he missing? He seemed to be on the right track, but he was missing something. So let's fast forward a few decades and find out. So at about the same time that Aretha Franklin was singing this classic, on the other side of the Pacific, there was another movement underway. So this guy is a chap called Taiichi Ohno. And between 1948 and 1975, him and E.G. Toyoda developed the Toyota production system, which later became lean manufacturing in the US and eventually led on to lean software engineering, as many people will be familiar with. Now, he had a somewhat different attitude to workers than our friend Taylor. This is a nice quote from him. People don't go to Toyota to work. They go there to think. So I guess he imagined that his workers had some mental capacity. So in 2001, Toyota wrapped up its philosophy and values and manufacturing ideals into what it called the Toyota Way. And there are 14 principles grouped into 2 key areas. Now, this talk isn't about Toyota or lean principles for that matter, and I'm not going to go into everything here, but I really highly recommend that you do. If you search for the Toyota Way, you can find this online. The Wikipedia page for it's excellent. There's a bunch of material and fantastic material available through Toyota. All of this stuff is open and available. What I normally do at this point, but really struggled to get the audio to work effectively over Zoom, was the I'm just checking. Oh, there we go. Sorry, my picture, my little monitor froze for a second there. I wasn't sure if you could still hear me or see me for that matter. So the what I normally do is play a video at this point, but I really struggled to get that to work through Zoom effectively. So we're going to go into it separately on each point. So what is the Toyota Way? As I said, it breaks down into 14 principles that are grouped into 2 key areas, what they call their pillars. The 2 pillars of the Toyota Way are continuous improvement and respect for people. Needless to say, maybe one of those is perhaps what Taylor might have been missing. So continuous improvement, this is their constant effort to improve their process and reduce waste. They achieve this in a number of ways, and some ways seem familiar from our earlier exploration of Taylor. So become a learning organization with Hansai, which is known as reflection, and Kaizen. The process of becoming a learning organization involves criticizing every aspect of what one does. Nothing is sacred. They constantly reflect on practice and look into ways of improving their approach. They have a well-known suggestion system at Toyota, which is a good example of this kind of continuous improvement process. And the Toyotas are encouraged to make suggestions to reduce waste or improve quality. They're actually asked the question, what is the smallest thing you could do today that improves the way you work? Now, Toyota, last time I checked, have roughly 300,000 employees worldwide, and they've been running this system since the 70s. Amazingly, Toyota get 1 million suggestions year on year, which is incredible. And what's more is that I mean, think about that. That's like 3 roughly per user, per employee on average. And what's incredible is that over 90% of those ideas are actually implemented on an annual basis. And one of the reasons for that is that Toyota, as they describe it, they encourage action over overthinking, basically, or hopefully a combination of the two. But essentially, don't just tell me that you have a good idea, go and do it. The employees and the people on the floor are empowered to implement those ideas. This is because they respect their frontline staff as the most qualified people in the organization to make those suggestions. So Nemawashi, building consensus. So when problems are discovered, they have this simple process that they follow. They head straight to the place of the problem to see what's going on. Now, at Toyota, this is normally seen when an employee pulls what's called the andon cord. So the andon cord is normally a stripy yellow and black rope that runs all the way above all of the stations in the factory. And if you're working and you notice a problem, you notice a quality problem, you notice an issue, you reach up and pull this cord, and you literally stop the whole line. And that sets off an alert, which then allows everyone to kind of focus in and know exactly where the problem is. They're then going to have a conversation. So normally, because the line has stopped, everyone gathers around and they have a conversation to try and identify what the underlying cause is. They consider a broad range of alternatives by pulling in other staff if they need to. The line is stopped, so everyone can focus, obviously. And they then build consensus on a particular problem, on a particular potential idea for how to fix this, or an experiment they're going to try. And what's really important here is they don't just come up with an idea of like what they're going to do, but in each case they have to discuss, how will they know it's done? What's the end game? How do I know that that thing that I want to improve, that quality problem, is fixed? Is it as simple as, well, a machine will switch on again? Or is it something more nuanced, like a performance change? I think we can improve the performance on this, this station by 10%. How do we measure that? After taking the time to come up with a proposed solution, they always go for the thing. They go and do it quickly. They get in there fast and get the line back up and running. And then once there is consensus around that solution, it is then built into what they call standardized work. So, wait a sec. Let's go back. Well, I'm going to talk about standardized work while that little joyous animation plays out. So what's amazing about this is standardized work. Well, that sounds a lot like Taylor. Standardized work sounds a lot like what Taylor is doing and talking about, because actually it's a really good idea for workers at different stations to work in similar ways. It doesn't make sense for all of the workers to work in different ways. Doesn't make sense in software for us to do things in 1,000 different ways. We support and use things like, coding styles, linters, all of these tools which essentially help us work in consistent ways, because there is benefit in doing that. But standardized work is actually seen as, so I'm seeing if I actually have, slide's gone missing. There we go. Standardized work at Toyota is actually seen as an empowering tool. This is not a way of working which is dictated to the employees. It's a record of the consensus. It's a record of how we are working collectively, not a diktat to tell them how to work. And standardized work at Toyota is absolutely foundational. So in this case, we've got a little factory scene here. stuff's been working. And if you notice behind me, the line suddenly stopped because this dude here, fun trying to point at things in a green screen, this dude here noticed that it was that there was a quality problem. There seems to be a little notch in his box. So as a result, his manager, they wear wheelies, is what I think they're called, glides over to and says, "What's up?" They then look at that, and they have some ideas on what that might be. But actually, what's going to happen here is the manager is going to be questioning the employee, because they come at this problem from different perspectives. The manager has this big picture view. The employee is the expert of his station. So they're going to have this conversation. Well, what do you think it might be? Well, I think it could be that. Are you sure it could be that? I think that probably looked okay. And that's because they have those different perspectives. Which point maybe they decide it might be Jenny's fault over here. So they come over to Jenny and they say, "What's up? It seems like there's this little dent in the in the box that's going downstream." And they all look at the thing together. "Oh well, look, actually, there's the problem right there." At that point, they come up with an idea. How are we going to fix this? How are we going to stop this from happening again? How are we going to improve quality right here? And then they continue. That goes into any changes to the ways they need to work, go into their standardized work. So now they've found a potential source of the problem. The manager asks, "Yeah, what can we do about this?" And there we go, standardized work. So actually the standardized tasks and processes, as they describe them as the foundation for continuous improvement and employee empowerment. So they talk about this relationship between the manager and the employee as a core thing, this mutual respect. I respect, as the manager, your close-up knowledge and ability and dedication to solve the problem. And as a team member, I respect as the manager to the manager, I respect your big picture perspective that allows you to ask the tough questions that guide me to a solution. So if you didn't get it already, I said that there was a superpower. I said the top thing, the thing that we really need to do, and I didn't tell you what it was. Well, unsurprisingly, we need to collaborate. We have to work together. So let's tie this together. Let's think about how we might make product ownership less of a one-man show or a one-person show. So you start by bringing a hypothesis to your team, an idea that might solve the problem or bring you closer to a goal. The team's job is to figure out the simplest way, the minimum output, to validate or invalidate this hypothesis. And they do this with an experiment. This provides learning, and that learning is the outcome. The team have not failed if they invalidate the hypothesis. Learning is the outcome here, and learning will always get you closer to your goal. Knowing what doesn't work is just as important as knowing what does. As you learn more, you'll be able to have more certainty in your hypothesis, or as the scientific community call it, consensus. So you build a consensus around product knowledge as a whole team collectively. No one becomes the one source of knowledge. The knowledge is distributed collectively around the team. So with that inspiration in mind, I created my own pillars of collaborative product ownership. Pillar 1, respect people. You respect people. Don't bring your team solutions to implement as a product owner. Show them that you respect their ability to solve the problems you bring them. It's literally their job. Embrace uncertainty. Don't bring them solutions. Bringing someone a solution is fake certainty. Bringing a solution is saying that we already know how to solve this problem. Well, you know what? In reality, you probably don't. You think you know how you have a solution. You think you know how to solve this problem, but you don't have a solution until it's solved. And what's worse is creating fake certainty around around a thing, around a potential solution to a problem. That fake certainty not only increases the risk because we don't actually accept the inherent uncertainty that's right in front of us, but also it reduces the opportunity for serendipity because we pretend we know everything. We're not looking for the other directions, for the opportunities. And those opportunities might be just what give your product the edge in a competitive marketplace. So how do we overcome the uncertainty? Well, we accept that there is uncertainty. We accept we don't know. And we use small experiments working with the team that will gradually build a shared understanding of the problem space throughout the team. And then continuous learning. With every experiment brings us learning, even if it invalidates a theory. And learning will always move you towards your goal, even when it seems you haven't moved. Shutting down all of the paths that you don't want to go down is as important, if not more important, in many cases, than just finding the right one all the time. And then no complacency. Allow consensus to build naturally across the team, but ensure it is safe to question everything, even the things that seem certain, especially the things that seem certain. Don't get complacent. So product owners can respect the people on a team by collaborating with them on solving problems and embracing the uncertainty of reality. Teams can overcome uncertainty with small experiments to test their hypotheses, which leads to continuous learning and builds consensus on the validity or invalidity of a theory. But no team should ever be complacent with the present state of understanding, and it should always be safe to question anything, however certain it might seem. So at the beginning, we had a little chat about the single ringable neck, the one throat to choke. You see, in a team where everyone is the product owner, in a team where decisions are made by consensus, collaboratively, based on a shared understanding of the strategy and direction, in those teams, everyone is a member of the team. It's easier to be a team member. It's easier to collaborate. It's easier to work with everyone when everyone is taking responsibility themselves and no one is being made accountable. So to the product owners out there that are thinking about maybe moving to becoming more collaborative, what I say to you is welcome to the team. And with that, I thank you very much for your time. And I think there's probably about, am I right, 5 minutes left for any questions if people have them. I'll see if I can pull up the chat if people want to ask. I can see the chat now, so people want to use the chat in Zoom, or can I don't know if they can send questions to through to someone who can ask me them. I know people are looking on YouTube and other places. Slack, yes, Slack. I can't see. I can only see. Oh yeah, I'll go to Slack. I'll pull up the Slack channel. Wait, let's see. Are there questions in Slack that you can see? I just have to use it on my phone. Apologies. Let's have a look. Oh, there we go. Yeah. Oh, well, I can cope with that. Thank you very much. Do feel free. We've got like, I don't mind standing here. I could stand here just really stony faced for a few minutes and see if questions appear in the thing. You're more than welcome. I will hang around in the Slack channel and around in Slack generally throughout the day and throughout the next few days. So feel free to hit me up on there and ask me any questions. You can. Oh, there is. Is there? Oh, in the chat, in the other chat. Ah, there we go. The product owners not usually come from IT or the departments we make software for. Well, okay. Well, depends on how you see how you're organizing your organization, because we tend to have this kind of weird thing. I think I highlighted that earlier in the talk. The IT teams say, oh, the business, there's the business, and then there's IT, as if somehow they are divorced of one another. My feeling would be that the product owner is a team member. Okay, so they are a team member and they are part of the team. They're not they shouldn't be ideally separate to they are separate from the customer. There's nothing wrong with having an actual customer, like an actual person from those teams embedded on your team as well, who's responsible for as an additional SME and someone there. But the product owner is normally somebody on the team. Now, I would advocate that there isn't someone with the title product owner on your team at all, actually. I would say that the role is best filled by individuals who perhaps you might call SMEs, subject matter experts, people that really know the space. A good example of that was I worked for a number of companies in the kind of finance sector. One was a company that was producing an app that allowed you to see like what your current pension value, the value of your pension plan was, and like the estimated amount and how much you could save and update it all. Now, all of that stuff that's obviously really very domain specific. Like unless you're in that field of finance, many engineers aren't, you don't necessarily know how to make those things. So having a good SME there who could advise and work with the engineers on getting the calculations right and things is obviously critical. And they also knew they were also the product owner. So there's an example of like a role, like a good role of somebody with expert knowledge. But I would say that normally the product owner is someone on the team, is a team member within your traditional IT organization, if that's what you've got. But ideally, your organizations are not necessarily structured around those functional boundaries. So you'll end up, yeah. So they're not kind of structured around that. All right, we have a minute left. I'll happily stand here for a minute. Yeah, absolutely, no problem. All right then. Well, thank you very much again. Feel free to hit me up in any channel you find. I'm relatively Googleable, so you can harass me online if I've said something offensive. Thank you very much.
Hi everyone, and welcome to my talk Going Fast and Cheap with Bots, Sanity and Kubernetes. My name is Olav Nybø. I'm a senior consultant and partner in Novanet. For the last couple of years, I have worked for Thon Hotels, and some of the technology I'm talking about here today are things we are using in their systems. On my spare time, I love playing games and MMO games in particular. For quite some time now, I've been playing World of Warcraft Classic. This talk is not about the game, of course, but I will use a tool I made for my guild as an example to show how we can use some, in my opinion, pretty cool technology to go really fast. When developing this tool, I did not want to spend too much time on the coding. I wanted to go fast. And being a hobby project, it had to be cheap. And I selected Discord, a voice and chat application for the UI, implementing a text-based chatbot, Kubernetes to run the bot, and finally for the data, I chose the headless CMS Sanity. But to set the stage and make sure you all understand what I'm building, a few words about what World of Warcraft is all about. You create a character, then you enter a huge world and play the game for a very, very long time to level up your character and to make it stronger. And finally, you will reach max level and you are ready to start for what for many is the real, which is raiding. Raiding is an activity where 40 players venture into some specific area of the game where there are particular hard monsters that the 40 players need to cooperate and coordinate carefully to be able to successfully defeat. Raiding in World of Warcraft Classic is a lot of organizing. That is making these 40 people work together. Voice communication is considered a necessity to be able to make this coordination happen. That is, we need to be able to speak to each other to communicate fast and well enough. A headset with a microphone, a voice and text chat application, not too different from Slack or Teams, is very commonly used when raiding. To be able to routinely gather 40 people to do these raids, most players join other players in guilds. And this is another area where the need for organization comes in. There are typically more than 100 players in such a guild. Each of these players can learn different professions. A profession gives the player the ability to make things that can be essential for raiding. One of such a profession is alchemy, the ability to potions and elixirs that are really useful in raids. To be successful as a group, it is really helpful to have knowledge of what resources are available to the guild. What can the different players do? So I wanted to make a tool where I could ask, do we have someone to make this and that potion? Who are they? And then I can ask them to help me out. So what I needed was a simple UI where the gamers can search for crafters of recipes. To make this happen, I needed somewhere to store the data, and I needed a UI for entering and editing of the same data. Finally, I would need somewhere to run this, some sort of platform. My experiences from building this system and my choices for those 3 building blocks is what this talk is about. Let's start with the data, as this will help explain the requirements better. I didn't opt for a regular database for this. In fact, my selected tool was Sanity CMS. Sanity is a headless CMS system, and in my opinion, a wonderful product. Yes, it may not be built to serve as a database, but it has a strong emphasis on the data model of your content. As we shall see, it automatically provides a very nice user interface for interacting with the data as soon as we have the model in place. To get started, you simply use npm install as shown here to install the Sanity CLI tools. And then you do a Sanity init and we get a starter project that will produce something similar to this. Here we can see the Sanity Studio, which is the tool that we build to both to interact with our data in the database. Here we can see I have defined my different document types. I have players, that's the people or persons that are part of my guild. And each of these players, they can then have one or more tunes. That's the characters that they are playing with inside the game. If we look at one of these documents or one of these tunes, we can see it has different fields of various types. I have text fields and I have here a back reference, a reference to another document, to the owner or to the player of the owning this tune. We have switch controls for Boolean values, and we have drop-down lists, which is really implemented as strings with some constraints, as we shall see. And here we have a list of recipes for that tunes, the recipes that he can make. And this is then a one-to-many relationship in our database. Even if Sanity is kind of like a document database, we can model one-to-many relationships between the different document types. And the recipes itself can be seen down here with another set of fields. This tool is then deployed to the Sanity servers using simply on the command line sanity deploy. That's all there's to it. And we then get this user interface hosted at the Sanity servers. But while we are developing the tool and at the same time developing our data model, we will run the same user interface locally on our own machine. So here I'm on localhost, and I have, if you noticed, I have removed the recipe, and I will use that as an example to show you how easy it is to add something to the user interface here. So let's look at the code. This is what you get when you do that initial npm init. The most interesting part is this schemas folder, where we have the root document, the schemas, defining the start of our database model. It is developed in regular JavaScript. Mostly we define different objects that will then define our database model. So my types here from the create schema function, the different types of my database. I have players, tunes, and some other types, and then finally the recipe that I have commented out here, just to show you how this works. So I add the recipe back, and we can see here we used standard JavaScript import statements to import the different schemas for the documents into our mains. Let me save this. And we can see here on the recipe how we define a recipe. I export it as the default for this module and give it a name and list it as a document type. And here add an icon. Just use any regular icon library. In this case, I'm using React icons and game icons to get this scroll icon that we can see in the user interface afterwards. And then we list all the fields of the document and again we just use simple JavaScript object declarations to list the different fields. So name with the type string, we have a profession, and that was the drop-down list that we saw earlier, and this is then constrained to the different allowed or the different professions that are available in World of Warcraft. So we have alchemy, enchanting, and so on. And we can have number fields and Boolean fields and all the types that you would expect in a database. We saw that we had a reference from the tune to a list of recipes. So I will also go in here in the tune definition and then add an array of recipes, or an array actually of references to another document type, which is the recipe document type. So this is simply how we then add something to our model. We can then go back here. I didn't show that maybe. I have started here in my terminal. I have started the Sanity local web server using just sanity start. It will then compile my files and immediately watch, and I will also watch for any changes that I do to my schema, and immediately update here the running user interface. To see this in action, we can go into a recipe here, and here we see I have intentionally made an error. I don't want the field name to be notes 1, 2, 3. So let's go in and change that. Find the recipe and find the notes field, and here we have the title 1, 2, 3. And if you look carefully down here, you will see when I save this, it will start rebuilding. Down there it starts compiling, and we can also see that the user interface here is rebuilding and automatically updating. So all of this gives us a very nice experience developing both the user interface here and the model at the same time. We can do customizations also. It's very flexible, the tool. We can, if we look, the default presentation of a list of documents is like this, where we just list the document name, the main field. But if we want something different, we can easily configure a different presentation of the document types. So we have, I didn't get that right. Okay, let's skip that. We see here that in the tunes list, I list more attributes from in the main presentation here, and this is done using the preview definition, where I define what should be used in the preview presentation in the user interface, where I list the different fields where that I'm using, or I want to use or display in my presentation of the tune type. And then I have a function, a prepare function, where I can build up again a JavaScript object consisting of title and subtitle, and then I just do some string concatenations of the fields here, and then I get this presentation in my overview. So underlying all of this, there's a database, and they have developed their own query language. They call it Grok. Again, it's JavaScript based. So let's have a look at how we can write Grok queries. The most basic query is star, that give me all the documents in the database. And we can see here right now I have 524 database. If want to constrain that a bit, we use this like this. Now I'm constraining the result to just document of type tune. And we can run that, and we should see that we get fewer items back. And yes, we get 14 documents back. We can even further constrain this. Let's say I want to do a kind of join operation. So I want to now get all tunes that have in their list of references to recipe document, they have at least one document with the name stone scale oil. So this is how we do a kind of joins in, and there I got something wrong. Yep, I'm missing a tick there, and then we got our query, and we can see we have three tunes in my document database that has this stone scale recipe. But we get a lot of different fields back here, also system-defined fields, these created at for the document and so on. And we may not want that, so we can then do a projection and select only the names. I add then or define the projection as a JavaScript object with the name. That's the name it will get in the result, and I want to pick the field that has the title name. And then we can see we have limited our list to just 3 items and the names of these crafters. And we can do similarly here. We can also display fields from other objects. So let me then also display recipes. But as we saw earlier, the recipes is a reference to another document type. So we only get that reference initially. But if we then dereference that reference using the arrow operator, we can then go into the related documents and pick out attributes from that document. So now I'm picking out just the recipe name from the referenced document, and we get a list of the crafters and a list of the names of the recipes that these crafters can make. So back to the presentation. Okay, so we have seen that Sanity helps us go fast, but is it cheap? You can certainly start out cheap. I'm using the standard plan, which includes 3 users of the Management Studio, which is enough for me, and the request quotas on the API are quite sufficient. But of course, as your requirement increases, the price goes up, as can be expected from a commercial product. Sanity is built and marketed as a CMS, not as a database. The lines gets kind of blurry when we talk about a query language and doing joins of related data and so on. But to be clear, I'm not advocating for dropping all your databases and use Sanity for everything. In my opinion, it is best used for your own content that you want to display on, be it a web page, mobile, or any platform, but content that you own and want to display to the world. I would not store transactional data or something like that in Sanity. I don't think that would make much sense. It should be used where it fits, and it is a CMS at heart. You should also keep in mind that access control is limited in the free plan. You can define your dataset as public, and that means it's open for read for everyone, or private. But then you need a special token to access the data, and everything becomes private. in the more advanced plans, there are more options, but it all depends on your requirements. So, the user interface. We were already using Discord. The guildies already have an account there and use it for both text and voice communication. And Discord, like most chat systems, can be extended with bots that can provide all kinds of functionality. A Discord bot provides the user with a command line interface immediately available to all the users of my Discord server. There is no need to ask them to install anything. A bot is simply an application that once registered and authorized with Discord and on your Discord server, then it can listen for certain keywords in the text chat. When it sees a trigger word, it will pass the text, do some processing, and send a reply that will appear in the text chat. The processing the bot does can be as smart or as dumb as you want. The name bot may lead to thoughts of very advanced AI and such, but a chatbot is really just something that can accept commands and produce some response. It's entirely up to you to define or to implement any smartness in your bot. In my example here, I have a command crafting and the argument stone scale. This is then sent to the bot that will do its thing. In my case, it will go to Sanity and do some lookup on the data store there, and then build a reply that is then sent back to the Discord channel where it was sent from, and give a reply with, in my case, who can make this stone scale oil. And we see here we had the same three tunes that we saw earlier. So my building blocks are now Discord, where the user enters their command, which is then sent to my bot that goes to Sanity and looks up the requested information for the user and display the result in the Discord chat. Discord has a very detailed and good documentation on their REST API, but they have auth endpoints that can be used for authentication, and there are a lot of features available directly through their HTTP API. But as mentioned, I wanted to go fast, and I prefer to use the higher level NuGet package, Discord.net, which is a very nice library that builds on top of the raw API. It makes developing a record bot just as easy as developing a regular .NET Web API controller. In fact, the programming model is very similar, as we shall see. To do queries against the Sanity API, we use another NuGet package, Sanity Client. The package is written by myself. It is a .NET client that takes care of all the details of sending a query to Sanity and to do the JSON deserialize the return JSON documents into regular .NET classes. Let's have a look at what the bot implemented using Discord.net with queries in Sanity looks like. So here I have my bot application where it's just a .NET Core console application with many of the features that all who knows and are used to .NET Core development will recognize quite immediately. In this case, I start with registering all my types into the .NET Core dependency injection mechanism. We don't have to use dependency injection, but I like using it, so I'm using it here, calling this configure services method, where which we can see down here below, and it creates a service collection, which we know from .NET Core development otherwise, and call registered services, and then finally builds the service provider. Let's have a look at this registered services so we can see the types that I'm registering here in my bot. I start out by calling the extension method on the Sanity client to register my Sanity database. It needs a project ID and a dataset and a token to identify the correct connection to my Sanity database. Then I add the Discord classes. First we have some standard library classes, and then finally the command handler, which we will look into in just a second. And then I will add different repositories and a query, which will then use the Sanity client that we registered to do the queries and get data from Sanity. So let's head back first to our main, and we have then registered our types, and we do then immediately we resolve the Discord client, set up some logging, and I do an initialization of my recipe repository, and then we do the login towards the Discord API. You can see here I read from my configuration a bot token. When you start developing Discord bot, you first need to go to the Discord pages and fill out some registration of your bot. Anyone who has done any work on OAuth will probably recognize this. You put in your name, you enter what permission the bot should ask for when it is authorized in a Discord server, and you get back a client ID and you get back this bot token that will be used as an identifier, and it's very important that you keep this bot token very secret, because if someone else can get to it, then they can impersonate your bot. Then we start the client, which will then connect to the Discord servers, and I have a little output here to the log. I will explain later in the presentation what we are doing here with this log line. And then finally we call the install command async on the command handler, which was the third class we registered for Discord. Here we simply set up the function. This is the main command handler for my bot. So we set up the function that should be called by the library whenever there's an incoming command from the Discord into my bot. And then I call the add modules async. This will do auto discovery of all the modules in my application. Modules can be compared to anyone who knows any .NET Web API controller development, and a controller and a module is very much the same or similar concepts. For each of the command handling function, it's more or less boilerplate code. I define here that I'm looking for anything that starts with a bang. So my commands should start with a bang so that I don't pick up on normal chat. If the command starts with a bang and then followed by my keywords, I will match it and reply and try to reply to it. And then we just call the command. And as I said, we have these modules. A module is something that inherits from module base, and that makes it discoverable by the auto discovery that we started earlier here. Each of my modules should have a group attribute defining the main verb that we are triggering on, or the main word we are triggering on. So my bot here will trigger on bang crafter, and then it will try to match any of my command methods down below here. Each of the command methods is identified by this command attribute, and they can then have different arguments. And the Discord.net library will do something similar to model binding from controller APIs, and map any and do the mapped typing, or map strings to string arguments, numbers to numbers, and so on. It has a support for a number of different data types, and it will try to call the function that most closely match whatever the user typed into the user interface. I have a breakpoint here in each of my command methods. So if we then quickly start the debugger, we see here that it's starting up. Just a second and it will be running, and it says it is ready. So then I go into the Discord application. I have different Discord servers. A Discord server is similar, if you know Slack, it's similar to a workspace in Slack. It's more or less the same thing. And in my Discord server here, I have installed the bot and authorized it to listen to these commands. So I type crafter of stone scale and hit enter, and we should then see, yes, it then will match because I typed crafter recipe, it will, or the recipe name, it will match with the first method here. Do some simple argument validation, and then we do a query against the Sanity API, and from the result from Sanity we build a text response that is then sent back to the channel where I type my command. So we got back the following: craft stone scale oil. I did some mapping here. I read stone scale, and then I will look up in the available recipes and find that stone scale oil is the one matching, or most closely matching stone scale. And then I get the names of the crafters that can make me this stone scale oil. Same if I here type crafter, I misspelled that, crafter stone scale and 1, 2, 3, so I have a number, then it should break on the other method, because it has done this model binding and found that there are two arguments, a recipe stone scale and a number 1, 2, 3, and it will simply here just echo back the text or the values that I entered. So it will reply, well, you sent the recipe stone scale and number 1, 2, 3. So we have seen that developing a user interface using Discord client is very, very fast. There's very little code that we actually have to write. We can focus solely on the business logic. But is it cheap? Yes, definitely. It is as cheap as it can be. It's completely free. So we have a system consisting of Discord, a bot, and Sanity. Both Discord and Sanity are software as a service, and we don't have to worry about running them at all. They are running on either on Sanity or on Discord's servers. The guy in the middle, however, the bot, he needs somewhere to live. Kubernetes is my clear preference for running services these days. Yes, some knowledge is required and it may be overkill for the smallest systems, but going with Kubernetes, you know you have a platform that can grow with your needs. But wait, you said going fast and cheap. Yes. A couple of VMs are required to run a Kubernetes cluster, but as we shall see, it's not that bad. I have a MSDN subscription with included Azure credits, so choosing Azure was a no-brainer for me. There are many VM sizes on Azure to choose from, but I have picked a smallish but not too small VM, the B2S. I would not go too small because each node in a cluster there's a fixed amount of resources that will be used for the system itself. So on a small server, the percentage used for this gets bigger. Choosing the 4 gig sized B2S looked okay to me. I wanted to squeeze it into my monthly included credits, so I opted for 2 nodes in my cluster. The recommended, however, is at least 3, but well, it's a hobby system and it seems well to work well enough with the 2 nodes. However, you should be aware that region matters. Both Beer and Azure VMs are expensive in Norway, so make sure to check prices in the region you have selected before you buy. Well, Kubernetes is a huge area that could easily fill the whole talk alone, but there's one particular area that I have used for my project that I find very useful and I would like to share with you. Operating systems have used the file and folder abstraction for other things than just plain files for a long time. By implementing a driver, we can use the file system abstraction for other things. We can implement a driver that let us read secrets from Azure Key Vault as if it were local files on our disk. Each secret becomes a file in our file system, completely transparent to the application. Azure AD Pod Identity is another service we can install in our cluster. Using Azure AD Pod Identity, we can connect pods with managed identity and through this we can control the access rights for each pod to Azure resources, such as Key Vault. So I can say that this pod, these white brownish pods, should have these access rights, and the blue one another set, and the green pod maybe should have no access to the Key Vault at all. Combining the two, we can manage access to Key Vault and provide the keys to the application running inside the pod, completely outside the scope of the application. This ensures that the administrator can be left to manage this and the developer does not have to do anything special in his or her code. To the developer, it makes no difference if the code is running on his or her laptop or in a Kubernetes cluster inside Azure. The required service for mounting of secrets in the file system is dependent on your Kubernetes version. If you are on version 1.15 or older, you would use Key Vault Flex Volume. If you are on version 1.16 or newer, the one you want to use is Azure Key Vault Provider for Secret Store CSS driver. Let's see how we set up this. So we stop And here we can have a look at our deployment manifest for our bot pod. The part that where we define the integration with the key vault is here down below on the volume mount. We specify a mount path. I want that the key vault secrets should be present in the folder under the mount path kvmnt in this case, and I want a read-only file system. I would then define in my volumes section, I would then define that I'm using flex volume here in my pod. And I specify a driver, Azure/KV. I'm using a key vault. My key vault is named my name is Midgard key. And then I list the different secrets inside this key vault and the names of the secrets. So I want to have a file for the Discord token, one for sanity token, and one for demo secret here inside my pod. And when I then deploy this to my cluster, it will mount from the key vault and map the named secrets from the key vault into the pod, and they will all be available under the path that we specified in the deployment file. So let's have a look at this. I have prepared some commands. First, I'm running kubectl get pod to list the pods inside my cluster. We can see here I have the Midgard bot pod running. Let me then do a kubectl exec, which will then run a command inside the pod and specify the pod name and then the command I want to run, which is ls to list the contents of the kvmnt folder. And this will now run inside my pod. If I can type the correct command there. So we see here down here in the terminal, I got the response back. And in fact, I have 3 files: the sanity token file, the bot token file, and the demo secret file. Inside these files, we will now have the secrets from the key vault. So I again run kubectl exec, name of the pod, and then run the cat command on the file demo secret inside the kvmnt folder. And we run that in our terminal down here. And we see that the contents of that file, and in fact my secret is, this is from the key vault. So how do we then read these secrets in our application? And let's go back to the application here. And we use standard .NET Core configuration or we can use standard .NET configuration to read these secrets. The configuration system of .NET Core has a number of different extension methods that we can use to provide configuration sources for our application. In this case, I'm using add.json file, which you probably know already, to add the app settings.json source. And I use user secrets that we will be using for local development, and environment variables, and finally I use the add key per file. And the add key per file is designed exactly for this purpose, I think, where it can then read the folder I specified, again the kvmnt folder, and read each of the files located in that folder will be available to the configuration system as a configuration setting. So now we know, or you may see why we had this console write line where we read from the configuration and read a demo secret and display that on startup of the application. Let's first look at how this would look when we do local development. I would then use .NET user secrets and set this demo secret to this is from user secret, so we can see the difference when running locally and when running inside the pod. So I set that setting, and I will start my my bot, which will then on startup type or write to the console the contents of the configuration setting. And not too surprisingly, it works to read from user secrets, and we see here demo secret is this is from user secrets. We can see then how the exact same code, when it's deployed to Kubernetes, will then use the last config source. It works, configuration works like that always the last configuration source is used if the same setting is in several places. So in the cluster, it will always use then the add key per file extension method if the secret is present on that value. So we can then use, if we go back here and to the terminal, and have a look at the logs of the running pod inside my cluster using kubectl logs and the name of the pod, and I pipe that into less so that I see the beginning of this log file, and it should then read demo secret, this is from the key vault. So we see that the exact same application works without any modification to the application. It works when running locally, and it works inside Kubernetes without us having to write any special code that knows anything about key vaults, Azure, Kubernetes, anything. It just use these very simple abstractions and reads from the file system, and the administrator, as long as he configures everything correctly for the application to run, everything will just work, and we have a very clean separation of concern. So, oops. If I can get back to the presentation there. Okay, so to summarize, for the UI, I used Discord and bots, which is a quick way to get a user interface in place without getting distracted from the pure functionality. For the data, we used Sanity, which automatically generates the management UI for us, saving us a lot of work, and it's really quick to get up once you know the tool. And for running the bot, we used Kubernetes that provides a great platform that allows for growth and mounted secrets, which is a great security feature, allowing us to keep our secrets really nice and safe inside Key Vault, and while still allowing the developer to not have to worry about this. Thanks a lot for listening, and now we may have time for some questions. If you would like, you can then go to the Slack channel for conference room 1, and we can see, and I will try to answer any questions, should there be any. So, well, if you write something later, then I will, of course, try to answer that then. But it seems we are done. And, well, thank you all for listening, and have a nice day. Bye-bye.
Hi, everyone. Thank you for joining this session where we're going to talk about how we are building an open source government application platform in the cloud. We are 3 team members of the team that is building the Altinn 3 platform for the Norwegian Digitalization Agency. The team consists of members both from the agency itself and consultants from different companies. My name is Rune T. Larsen and I work for Accenture Technology. And I've been doing that since 2005. I've been working on the Altinn platform since 2008 and I was part of the team that originally built the 2nd generation of Altinn. I'm a developer and technical architect and I do most of my coding in .NET.
Hi everyone, my name is Nina Kilstad. I also work at Accenture Technology and I've been working there for the past 6 years. For the past 5 years I've also been working on the Altinn platform. I am a developer and technical architect and I like to think of myself as a full stack developer, but I do work mostly front end these days. Outside of work I have a 1-year-old who keeps me busy most of the time. When I do have some spare time I like to read and I've also dusted off my sewing machine in these times where we're staying so much at home.
Hi guys, my name is Stephanie Boidu. I've been with Avanade and the Altinn team since 2018. On this project, I've focused mostly on the backend part of our solution and also our integrations with Altinn 2. In my spare time, I quite like knitting, and that's a great hobby to combine with Netflix, so I do quite a bit of that as well.
So in this presentation, we're going to talk about what Altinn is, give you a little introduction for you guys who doesn't know that. We're going to talk about the project, Altinn 3 project, how that started, and our technical principles. We are building a new platform. We're going to go into details about the new platform, the components and the solution we are creating. And then we are going through the cloud architecture and components we are using as part of the solutions. Give you the current status and what we will do working on next. And at the end, we open up for questions. So please ask questions on Slack if you have any. So what is Altinn? Imagine you work for a government agency that needs to get data from the citizens of Norway. Maybe you want them to report their COVID-19 symptoms. And maybe you want a digital service online where that can receive that data. Then Altinn is the platform for you. Altinn is an internet portal for dialogue between the citizens, the businesses and the agencies of Norway. It's also a technical platform where the agencies can build and host the digital services. You can say that Altinn was one of the first platform as a service providers because it already started back in 2002 when 3 agencies joined forces to build a common platform for reporting to the government. And in 2003, the first generation was launched. In 2010, the 2nd generation went live. And during those years, more than 50 agencies had joined the platform, including the armed forces, the police, health, and many more, covering most of the government sectors of Norway. There are now more than 1,000 digital services available through the platform. And that includes everything from naming your firstborn to report on aircraft incidents. Almost all businesses in Norway uses Altinn every year. And as this diagram shows, almost everyone from 13 to 110 uses Altinn every year. In Altinn, everyone has their own inbox where they find their communication with the government. You also have a service catalog where you can find your digital service and what you need. Having this common platform is quite unique and is regarded as one of the reasons that Norway is a leader in digital government. One other good functionality is that every functionality is available through APIs. So there are lots of software vendors have implemented integration with Altinn. So you, as an example, can submit your tax report directly from your financial system. Gartner regards Altinn as one of the top 5 government technical platforms in the world. So back again to the agency and the need for having data from the government. What I'm just said, maybe you think that Altinn 2 is the perfect platform, but there are some limitations. we base the current platform on physical hardware. So even if our traffic varies from 100,000 a day to 2.5 million a day, we are scaled the same all year long. And as an agency today, you will need to make a digital service that is well supported on mobile and on desktop. But we are using InfoPath, and it's very limiting in what you can do with that. In addition, there is a limitation on what kind of process flow you can support for end users. It's quite time-consuming to do testing, because every time you do a little change, you need to deploy to the test environment. And version control is done through SharePoint, so it's very difficult to understand what kind of changes you or others have done previous on your digital service. And when you're done testing, you're ready to go in production. In today's platform, you need to get help of a technician to deploy it. And those are some of the limitations we are started building on the next generation of Altinn. So this project started already back in 2016. And we had at that time looked into what kind of product could replace InfoPath. But we realized maybe we should try to build something from ourselves, from scratch. So we did a small proof of concept at that time, just verify, are we able to build a platform using ASP.NET Core? And we kind of, yeah, it's possible. And in 2018, we were ready to do a full-fledged proof of concept. We wanted to build a new platform using .NET Core. We want to use React as front-end. We want to use Docker and Kubernetes. And in the spring of 2018, we started to verify, are we able to do this? And during the summer of 2018, we were saying, OK, we were able to prove our main concept, that is, we are going to build a UI designer using React. So we then finalized the concept and getting ready to start a minimal viable product project. And that is what we are presenting to you guys today. So what is our concept on the new platform? So we will let the developers working for the agencies be able to develop by themselves or as a group digital services, deploy it to production as containers to a public cloud infrastructure. And all that without you needing to know programming or not need to know anything about cloud infrastructure. Pretty cool. So to do this new platform, we defined some architecture principles. And I'm just going to mention the 5 most important ones. So we want to be open source. We want others to use our platform and components if they want. Other agencies want to use it internally or maybe a different country. And we also want contribution from the agency that needs some features to the platform. So all our code is available on GitHub. All our issues are available on GitHub. And we only use tools and frameworks that are open source. The second principle is that we really want the platform to be loved. So we build with tools that the developers like. So we have chosen the most loved web framework according to Stack Overflow, React. We are using the most loved backend framework, that is ASP.NET Core. And we are using 3 most loved platforms, since we are using Linux containers based on Docker. And everything is built around Visual Studio Code. That is the most loved development environment. We truly love working with our platform, and we believe that others will too. These are some of the tools we have been using in our platform. The third principle for a new platform is we're going to build everything as microservices. We want to be able to scale independently the different components. We want to be able to deploy them. We want to be able to have teams responsible for different components. So every component is deployed as a microservice, and all the digital services are created and deployed as a microservice. The fourth principle is also very important for us, because we are going to end up with a big infrastructure in the cloud. And we are not able to run that by ourselves if we're going to manage it as a team. So we favor using managed services available in Azure. As an example, Azure Kubernetes Service. Stephanie will tell you more about that later. And the last one, application owners will be isolated from each other. We don't want an application owner to be able to affect the service for others or be able to access data for others. So we have isolated infrastructure for every application owner, and we also have isolated and separate data store for every application owner. Then Nina is going to tell you more about the solution we are building.
Thank you, Rune. Oops. All right. So we had our overall concept, and we had our architecture principles, and we had the proof of concept ready. And based on this, we started building our solutions. Altin 3 is made up of 3 solutions that work together. First, we have the Altin Studio solution, and this is our design time solution to create, develop, and deploy applications, or apps, as we call them. We have the Altin Apps solution. This is the collection of all of the running apps and the Kubernetes clusters on which they run. Finally, we have the Altin Platform solution, which provides the common backend functionality for the apps. So let's look now at how these 3 solutions work together to support the next generation of digital services for the people of Norway. So let's go back to this scenario of a government agency that wants to collect some data and they want to create a digital service to do this. And we'll see how we can solve this by creating an app using the Altin 3 solutions. Now, these are some of the key features that we want to support, and these are also some pain points from the existing platform that we would like to improve on. So what is an app in this context? Well, an app is a digital service in the form of a standalone application. And this application exposes some APIs, it has some sort of graphical user interface, and it runs in a Docker container. So to support this, we have created an app template. This is the starting point for all of the apps. The app template is built is an .NET Core MVC application, completely standard, and then we have extended it with some supporting libraries. These are projects that we publish as NuGet packages. Now, NuGet is .NET's package manager. And these supporting libraries contain things like the standard APIs that the apps should expose, as well as integration with the Altin platform. We've also added placeholders for custom logic and a set of configuration files that the app developers can use to configure the apps. The app also refers to a front end. This is a React application that is loaded from a content delivery network at runtime. All of the apps use the same front end by default. And the front end can then be configured to work with the specific apps. The front end integrates with the app itself via the APIs that the app exposes. So let's look a little bit at how an app developer could actually customize the app. As I mentioned, one of the ways to do this is through a set of configuration files. One of the most important configurations that we set up is the process. The process defines the set of tasks that the end user that actually uses the app must go through. So, for example, if we look at, think back at our scenario of a government agency that wants to collect data. So the end user might have to, for example, fill in a form. This would be a data type task. They might then have to confirm that their data is correct. So this would be a confirmation task. Finally, they might need to wait for some response from the agency that they are submitting their data to, and this would be the feedback type task. So these are the 3 task types that we support, and they can be combined in any way to create a process. Now, defining the process is done through the process configuration file. And when we set up our configuration files, we tried, where possible, to use existing standards for the format. For the process, we use the BPMN 2.0 standard. This is an XML notation for defining processes. We have also used the XACML standard for our authorization policies. And this is an XML standard for defining access control. Now, authorization policies can be applied to the entire app as a whole or to specific process tasks. So that was a little bit about setting up the app using the configuration files. Now, the app developers can, of course, also customize the apps through code. As I mentioned, we set up some placeholders for custom logic. Now, this is for things like validation, calculation, or pre-filling of data. But this is really just the beginning. App developers can really do anything they want as long as they can put it into code. For example, they could fetch data from the Altinn platform or from external sources. They could create and expose APIs, and the list goes on. And really, as I said, if it can be coded, it can be done. Now, let's take this one step further. I said that the apps all use the same front end by default, and then that front end can be configured. Well, imagine that this doesn't cut it. You can't configure the standard front end to do what you want it to do. All right, replace it with something different. Since we just refer to the app front end from the app, you can just refer to something else and load it at runtime. Or drop the front end entirely and have your end users go directly to the app via the APIs. And if we go even further now, nothing is really stopping you from doing the same thing with the app template itself. You could, if it doesn't work for you, you could replace it with something different. Maybe even a Java application. Now, personally, I would not choose to replace our beautiful, amazing .NET app template with a Java application. But joking aside, if the standard template doesn't do it for you, then of course it is possible to replace it with something else. And we see that in the future we might actually have a set of app templates using different technologies that you can choose from when you are creating an app. All right, so let's go back now and assume that you want to keep the app template and front end as is, and then just work on configuring it. Now, as we've said before, we want the UIs to be modern. They want them to work on both desktop and mobile. And one of the ways to configure the UI is by creating a form for collecting data. So, as Rune mentioned, we decided to build our own tool instead of using existing tools to do this. So we built a drag and drop forms editor using React. And this forms editor has a library of available components that can be dragged into the form layout and then configured. Now, currently we only support very simple forms with a single column layout, and we do aim to expand on this. When an app developer works on developing, on configuring a form like this, the actual form configuration and the definition of the form is stored in a JSON layout file. So this is our form layout file, and it defines how the form should look. At runtime, the app front end then parses this layout file and renders the form. Now, this configuration is for the data type task, so forms are for collecting data. But we do have the possibility to configure views for the other task types as well. So that would be confirmation and feedback. We have views for these, and the app owners can then configure the content that will be shown in these views. Now, so far I've talked about the apps, but how do we actually develop apps into complete digital services? Well, this is done in the Alten Studio solution. Alten Studio is made up of 3 parts. We have the designer application. This is the graphical user interface that app developers use to create and develop their apps. This is what it looks like. In the designer application, we have things like the forms builder that I just showed you. We have an editor for setting up texts, for language support. We have some support for simple code editing using an embedded code editor, and of course, deploy. Now, the designer application integrates with the repository application. This is where all of the apps in Alten Studio are stored. The repository application is built on Gitty. This is an open source code hosting solution that uses Git. And it looks like this, a little bit like GitHub. Now, each app in Alten Studio is stored in a Git repository. And when an app developer works on an app in the Alten Studio solution, they are working on a clone of the central app repository. And when they're done with their changes, they can push their changes to the app repository. Now, this makes it easy for multiple developers to work on the same app at the same time, and all of the files are version controlled, just like normal source code. We have set up a load balancer to route between the repository application and the designer application based on the URL that comes in. Now, building applications through a graphical user interface, drag and drop, it's cool. Unfortunately, not all of the functionality of the apps is supported to be configured through a graphical user interface in Alten Studio. In addition, some developers might actually like to use their own tools, especially when it comes to writing code. So we support local development, where app developers can use their favorite tools to work on the apps. So once an app is created, it can be cloned to your local computer where you can work on it. Once you're done, you can push it back up to the app repository for deploy. Now, one very important aspect of developing an app, which I haven't talked about yet, is testing. Apps need to be tested. And the apps need the Alten platform solution to actually run. So one possibility is to deploy the app to a test environment where the Alten platform solution is running. However, if you are just testing while you are developing and testing incremental changes, this could be very time-consuming. So, in order to support local testing, we have created a platform mock. Now, this can be downloaded and run in parallel with the apps in order to actually test the apps locally on the fly while developing. This platform mock is also used a lot by the development team when we're developing new features for the apps. All right, let's look at deploy. Apps are deployed from the Alten Studio solution to a Kubernetes cluster in the Alten Apps solution. Now, as Rune mentioned, each app owner or government agency has their own Kubernetes cluster to which they deploy their apps. And this is true for both test environments and production. This means that the apps of one agency do not affect the apps of another agency. And this is what allows us to provide self-service deploys all the way to production. Now, deploy is a two-step process. First, we need to actually build the application, and this builds a Docker image for the app and then pushes it to an Azure Container Registry. And this is done via an Azure DevOps pipeline, which you can see an example of here. Once the build is done, we can deploy the app to the environment that we choose. And this fetches that Docker image and deploys it to the specified environment. Again, done using an Azure DevOps pipeline. and now Rune is going to show you a little bit about the Altinn platform.
So the Altinn platform is the part of our new platform that contains all the functionality needed by the apps. We have grouped the functionality into different containers or microservices, and those are available through APIs. The first component is the authentication component, and that's responsible for authenticating user and system wanting to accessing an app. The component works as an identity provider for the apps, and this again is integrated with other external identity provider like the national ID port in Norway. The authorization component is authorizing access for every apps, the APIs and so on. And this is a SACML 3.0 policy decision point that reads the policy file defined as part of the application repository just mentioned by Nina. So every app will call the authorization point, and we will get a response saying if the user or system can access it or not. We believe that this component can be used in other type of scenario. It's available in our source code and could be used in everywhere else where you can use a PDP. Then you have the profile component where it gets the user information for the users. You have the register component where you find information about all the citizens and the businesses of Norway, often used in apps. We have the receipt component that provides a receipt for earlier communication with the government. And all those apps I mentioned now are based on ASP.NET Core. But the PDF component is in fact a Java application. And the reason for that is that we were not able to find a good enough open source PDF tool for .NET. So if anyone else will build it, we really truly appreciate it. So, and then we have the receipt component. The storage component, where you find the storage functionality for apps. This is where the user will end up storing their data. And this is also where the agency will retrieve their data through APIs. So when a user submits data in our app, the app will call this storage component, and it will be stored down to a separate storage account in Azure. So those are the components we have. And the next up is what kind of cloud architecture are we building? And Stephanie is going to give you the details about that.
Thanks. So guys, we're gonna move on to talk a bit about our public cloud components and our architecture in Azure. We're gonna exemplify this by looking at how we deploy our microservices. And so Microsoft actually established the first Norwegian data centers this winter, one placed east and one placed west in the country. This makes them the only large cloud provider with data centers in Norway. Given that they have 2 data centers, we're able to have redundancy within Norwegian borders. And this is great as we then can take on application owners that have a requirement that their data be stored within Norway. Another great thing about using the Norwegian data centers is that we get a lower latency in the communications between our on-premise and cloud solutions. And so Nina and Rune have told you guys about our different microservices. So we have the different platform components, and we also have the apps of our users and Altinn Studio. What I want to take you through is how do we get from a bunch of code on GitHub or Gitty to running services online. And the exciting thing here is that the concepts that I'm going to show you are the same we use whether we're deploying our microservices or the microservices of our users, the app developers. And so the first step, of course, is source control. We use GitHub for all the code that we're developing and Gitty for all the code related to the applications. At this stage, we also like to run analysis on our code. So we use LGTM, looks good to me, for security analysis, and Sonar Cloud to ensure that we have a maintainable code base. And that's just a few of the tools that we're using. And so once we have a new feature for the platform or an application owner decides it's time to build their app, a build pipeline is triggered in Azure DevOps. And so this build pipeline is made out of ready template tasks in Azure DevOps, making them really easy to configure. It's a two-step pipeline where the first step is building a Docker image, and the second step is pushing that image to container registry. Container registry is hosted in Azure, and this is where we store our live images until we're ready to deploy the microservice. And there are two important things I'd like to point out about the container registry. The first point being that we are a public platform, and our users must be able to trust that their data is safe, going back to the isolation principle. This is why we have a container registry for each of our application owners, where only their Docker images are stored. Secondly, a single Docker image might be deployed to multiple environments, so both testing and production. This is why we treat our container registry and all the Docker images as production resources, meaning that we set restrictions on what and who is able to access the resource, as well as which availability we're expecting, and also which region we're hosting the resource in. So next step, once we have the Docker image in container registry and we're ready to deploy the microservice, is that we trigger a release pipeline. This is also hosted in Azure DevOps. And this pipeline would use Helm to install the microservice on the cluster. But I do have a confession to make before we take a closer look at the release pipeline. Because we are an open source project, and we really like mentioning it because we really like that fact. But truth be told, we do have an additional repository which is protected. And this is where we store sensitive data such as Helm charts and instrumentation keys for some of our resources in Azure. And so this Helm chart and the other secrets are packed as an artifact and included into the release pipeline that way. What we see here is an overview of the release pipeline for one of our platform components. We can see that two artifacts are included in the pipeline. The first artifact is to identify which Docker image we want to deploy, and the second artifact would be the Helm charts from that repository I was just mentioning. So once we have the artifacts, we're ready to deploy this microservice to one of our environments. And what we can see here are all of our environments listed up. So in the first stage, you'll find our acceptance testing and load testing environments. In the second stage, we have the testing environment for our application owners. And then finally, we have production. And so for these various stages, we have different triggers. With regards to a platform component, a new release would go to the acceptance testing environments whenever a new Docker container is available or a Docker image is available. For our application owner testing environments and also production, we have weekly releases. And we also have some manual checkpoints prior to each release to ensure that we have people at work in case something was to go wrong. But the most important thing about this release pipeline is the tasks that it completes. And the most important task is that the pipeline would run a Helm upgrade or Helm install task depending on if the microservice has been deployed previously or not. And the result of this task is that a new pod will spin up in the Azure Kubernetes Services cluster, which brings us to the final step. So a new pod spins up in the Kubernetes cluster, and the referenced Docker image is pulled onto the pod, and the microservice starts up. And it's always ensured that the microservice is fully up and running before we terminate any pre-existing versions of that microservice. And this results in a deploy without any downtime. And so this is our overall process for getting from code on GitHub to running services online. And again, it's the exact same process, whether we're deploying our microservices, so our platform components, or the applications of our users. But let's take a look at how this looks in Azure once all the microservices are deployed. So what we can see here is an overview of how we've set up our infrastructure in Azure for our different solutions. Starting with Altin Studio, we can see that this runs in a separate Kubernetes cluster. And you can see the two services, Altin Designer and Altin Repositories. Within Altin Studio, you'll also find the virtual network. We have a key vault where we store secrets and certificates that are accessible by the microservices. And we have an ingress route to control the traffic onto the correct node running the pods. And then we have a load balancer to direct the traffic to the right microservice again. And I think that's the other way around, sorry. So the load balancer handles the incoming network traffic, so directing us to the correct node, and then the ingress route would direct us to the correct microservice. We can also see the connection here to the build and deploy or build and release pipelines that are triggered by our users when they're building and deploying their applications through Altin Studio. So the next component is Altin Studio, and I think this might be the most exciting part of our infrastructure. So what we can see here are two examples of application clusters, and they've each got 4 running applications each. So when an application owner decides to join our solution, they're given 2 Azure subscriptions, one for their testing resources and one for their production resources. Within this subscription, you'll find the Kubernetes cluster where they host their microservices or their apps. You'll find the key vault for sensitive data accessible by the microservices. You'll find the virtual network, the container registry where we store the Docker images, and you'll also find the storage account. In this storage account, we'll store all the data collected through their applications. And again, we have the ingress route to control the incoming network traffic and the load balancer. And common for these apps is that many of them would require the shared platform. And so the communication to get from the apps to the platform has to pass through an application gateway and then API management before reaching our microservices. And so what we can see listed here are our different services in the platform. Each platform component runs on their own Docker container. We do actually have quite a bit of communication within these microservices as well, especially to the authorization component to authorize the different actions. And so this communication is enabled through Linkerd, and we have an encrypted pod-to-pod communication. So this saves us from routing that traffic through the internet and then back to the same Kubernetes cluster. I'd like to draw your attention to the bottom component, platform storage. We can see that this component would connect to Cosmos DB or a storage account depending on who owns the data it's handling in a given transaction. We also have our connection to the on-premise environment, which is Altin 2. And so this is enabled with an express route. And this gives us a high-speed communication between our on-prem and cloud solution. And so looking at this infrastructure as a whole, there's a varying level of how consistent the components are. For Altin Apps, for instance, we'll be having new service owners or application owners wanting to join our solution, or we'll have requests to upgrade some of their components. And of course, we have the standard work like upgrading our Kubernetes services cluster or our version of application gateway, for instance. And we've struggled a bit with finding a good way to maintain our infrastructure. But recently, we started using Terraform. And Terraform is a great tool as it allows us both to provision and evolve our infrastructure. And even better, it's all written in code. That allows developers like us to take a much larger part in both setting up and maintaining our infrastructure. This is because we're able to read the code and modify it to suit our needs. And so looking at this picture, you can see that there are quite a number of cloud components involved in setting up our infrastructure. And of course, some parallels can be drawn to technology that we've used on-premise, but not always. And so when we've tried to select which cloud components to use, or how to configure our virtual network, for instance, we've had to base our decisions on the points that you can see here. And so I would say that the point right at the bottom here might be the most important one. So which components do we think have the potential to evolve along with our platform and the capabilities that we expect to deliver or offer in the future? And I think this says something about daring to imagine what the future looks like or dream about what we wish the future might be, even though we don't have it right now. And in some cases, it also means doing the necessary work to make sure that our needs and expectations are made clear onto those that are further developing Azure. And so here we can see the most central cloud components that we're using at the moment. And luckily, a lot of these components are fully managed by Azure. This limits the number of variables for us to tweak, as well as the time we need to spend maintaining these resources. And we would have never had the capacity to have this many new components in our solution all at once if we were supposed to manage them all ourselves. And my reason for emphasizing that these are the components that we're using at the moment is that we do have a quite high rate of change, I would say. So we started developing this solution before the Norwegian data centers were established. This means that we've had to adapt to which features would be offered in Norway and not. Also taking into account the rapid evolution of cloud technology, we're always prepared to swap out a component or to upgrade the existing ones that we have. And again, Terraform, as I mentioned, is a great tool for doing exactly that. Another important thing for us lately has been cost management with regards to these cloud components. Because if you're not shy when selecting a cost plan for these components, the bills could quickly add up. And so we've had to sit down and ask ourselves questions like, do we need the trace log from our backup function? And how long are we actually willing to wait to find log data that's more than 30 days old? And by asking these questions, we've been able to, sorry, lost the thread there. Let me just get back in. So asking these questions, we've been able to tweak our solution in order to save costs without compromising the functionality of our solution. And so I'm going to go on to talk a bit about some of the cloud components that we're really happy with using. The first one, of course, is Azure Kubernetes Services. And so as you could see from our infrastructure, we do have quite a number of Kubernetes clusters. And again, this is a great resource because it's fully managed. This means that we have very few responsibilities outside of deploying our microservices and managing them. In addition, Azure Kubernetes Services supports auto-scaling. So this means that our applications are able to scale both up and down depending on the load that they're facing. Once we've transferred all of the application owners from Altyn 2 to Altyn 3, we're expecting to have several hundred Kubernetes clusters. And so Microsoft's Azure team might have a bit more to do, but we should be able to manage just fine. We have Azure Cosmos DB. So this is a document database that we use to store metadata about the applications and their instances. Cosmos DB is said to be highly available, and it's documented to have an availability of 99.999%. Pretty high. And if that wasn't enough, it also duplicates our data into multiple locations automatically. As this database is hosted in Azure, you could say that we have an unlimited amount of storage, should we need it. And at Microsoft Build, auto-scaling for Cosmos DB was announced, and we're really excited to incorporate this feature into our solution as well. Finally, we've saved the best for last, application insights. And so you know when you have a bug and you're not quite sure where the root cause is or where to start debugging, well, application insights would be my starting point 9 out of 10 times. And so we use application insights to monitor our microservices. So this goes for both the platform components, Altin Studio, and also all the apps of our application owners. App Insights would draw out an application map, as you can see here, where we can see all of our microservices and also the communication lines between them. Another feature that Application Insights provides is that we can drill down to a specific time frame and see which requests are used the most often and also their average response times. Another great feature is drilling into a single request. And this way we can see how the request flows through all of our services. And these two features that I just mentioned have been heavily used during our load testing. We've been able to identify bottlenecks and unnecessary or duplicate requests as well. So I'm going to hand you guys over to Nina now, and she's going to share a bit about our experiences working on this project. Thank you.
So we've been working on this project now for a little over 2 years. And we are definitely some experiences richer, and we would like to share some of those experiences with you guys. So the first point that I would like to make is that working on an open source project has been really great. We have our backlog open on GitHub. On the right side here you can see a screenshot from just a few days ago. Having our backlog open on GitHub, in addition, of course, to our source code, means that we have gotten feedback and wishes from the app developers and government agencies that have been following this project at a very early stage. We've had app developers submit issues, and they can follow the progress of those issues to see how they will be solved. Now, since we also only use open source projects ourselves, we can do the same. So we can modify things to suit our needs. We also have a great insight into when new functionality will become available in the tools and frameworks that we use. Now, while having an open backlog on GitHub has been a really good thing, sort of plain GitHub as a tool for managing the project and managing the backlog has not worked that well for us. Currently, we are a quite small team, and that makes it manageable. But as you can see at the very top of this screenshot from our backlog, there are currently almost 600 open issues, and there have been a lot more. So actually managing this and prioritizing and seeing who is working on what has been quite challenging, especially previously when we were a much larger team. We've had to test several different plugins to work with GitHub, and we've ended up with a plugin called ZenHub, which we feel works quite well for us. Finally, a note on direction. And we would like to say that shifting direction mid-project can actually be a good thing. Now, to elaborate a little bit on that, when we started this project, we focused a lot around the Altin Studio solution as a tool to build apps. We focused so much on the tool and possibly not enough on the actual apps themselves. Underways, we decided to switch our direction to focus more on the actual apps. Now, this resulted in us having to switch also from focusing on users who do not know coding towards users who actually do know how to code. And I'm sure you've seen this reflected in what we've been explaining today. probably you would need to know at least a little bit of coding to properly customize your app. Hopefully, going forward, we can now continue building on the Altinn Studio solution now that our apps are more mature. All right. I'll hand you over to Rune, who will tell you a little bit more about our current status.
Yes, so it's now 6,000 days since Altinn 1 went into production. It's 3,500 days since Altinn 2 went into production. And there's over 2 years since we started these minimal viable products. So what is our status? Are we done yet? We went live on Monday, in fact. It's a great success for us that we were able to go launch this platform this Monday. So that means that the pilots are getting ready to deploy their first applications to the productions. So we are helping them out with the initial apps. We have around 600 open issues, as mentioned. And we are still working from home, but it works fine. And forward, we're going to focus on more stuff. Because, as I mentioned, we have more than 1,000 digital services on this old platform. And we want to move that to the new one. So we will focus on building more flexibility on the forms, being able to build more advanced forms, components, and so on. We will expand the types of process tasks we can support, like payment and signing, we will add, and many more. And this is an event-driven architecture, and we need to define how we're going to expose the events. So because the goal for us is that we want to have an event feed for every citizen of Norway, every organization, and every agency. And it's going to be an exciting task to build that solution. As mentioned many times, we are open source. Our documentation is fully open source that also. And on GitHub, you will find a link to the different documentation we have. And we will find a full detail about the requirements, both functional and technical requirements, the principles we have, the different patterns we follow, what kind of capabilities, both on the DevOps capabilities and the runtime capabilities of the platform, and all the components and code structure we are building. So every design details you find there. Go take a look. You'll find details about all the platform components. So, and you will also find the presentation we just had on there on a couple of hours. And with that, I want to thank everyone for joining. We're going to thank NDC for letting us come and present. And we are opening up for answering questions from Slack.
Yeah, so I can see we have a few questions on YouTube, so we'll start here first. The first question is, are the development teams centered around those microservices? So do we have an authorization team and a PDF team, and etc.? And so are the different teams available? Let's see, are they responsible for the different services?
And I guess the answer now, no, not yet. We have been, we are currently not that big team, and so we are covering more components, but there are special member teams that focus on different components. So currently, we have one team sharing all components.
And to speak of that team, we're like 5 or 6 developers, so it's not that big a team. I don't even think we have enough team members to have a component each. So another question here, let's see. So you mentioned that you don't do multi-tenant architecture. Is this due to a government requirement?
We, of course, investigate what the government agency needs and so on. And some agency would require that they have an infrastructure that is separate from others. So, and we want to support as many agencies as possible. And it's based on history on current platform that is not separated. We have seen instances of poor code in one digital service affecting others because of a high load and so on. So it's a natural by experience and some requirement.
Yeah. And so another question from Brian here is, since you're running several hundred, soon to be several hundred. We're not quite there yet, but it's coming. So since we're running several Kubernetes clusters and application insights and Cosmos DB, how are we hosting the costs? Do you want to answer that, Nina?
I think Rune has the best answer for this.
Yeah, so currently this is a governmental platform and it will be that. So how the cost is shared is kind of a deal that is between the agency and the Norwegian Digitalization Agency. And I think with the new architecture, it is more possible to split the cost if they want it to the different agencies. Currently, on the current platform, that's impossible because we are using shared resources and kind of saying that you are using 10% and the Euro 7 it's not possible. Yeah.
And we've used the examples of application owners with really large attachments, for instance. Should we share those costs or should they be responsible for paying for storing those attachments? And with their separate storage accounts, it's pretty easy to see, how much they're using and what it costs. So another good question here, let's see. Tom had the same questions as Brian, so let's hope we answer them. We have Cybernetics 100. So despite all the good work with the new Altin platform, what are some top challenges that still remain to be addressed in or by the new platform? We're taking too long to think here.
Okay, well, one thing that I think was barely mentioned at the end was this idea of being able to build the services without actually having a lot of technical background. In the existing application or in the existing platform, we do, yes, there are flaws, but it is possible to build a complete digital service without actually having to know any code. I would say that if you're going to build an app in the Altin 3 solution right now and you don't know anything about coding, it would have to be a very, very simple app. So extending that and making it easier to actually build the apps, that's probably something.
Yeah, we have seen during the development time that when making it user-friendly, it limits the flexibility. And I don't believe that we really want to go 100% usability, what we talked about, because I think it's easier. We are learning kids to code. We can learn the agencies to code also.
Pretty much, yeah. Let's see. And so Brian made a comment here regarding the costs. He's saying, oil money. Say no more. I guess that might be true. We have another question here from Stefan. So could you say anything about the advantages that you gain from hosting in the cloud versus on-premise?
Do you want to take this one?
I could so I was talking about application insights, right? And I think, so we're using that only to react to instances or incidents at the moment. But using this as a predictive tool as well, I think would be great. And also for our agencies to get more feedback on how their applications are used and when they're used, to be able to collect more data about the citizens or the companies that they're interacting with. And I think another great thing would be to run larger analysis on the data sets that they're collecting, because that's pretty easy now that it's in the cloud. Do we have any other advantages?
So I think the last thing you mentioned, that because having one common platform, in theory, you have enormous advantage doing big data analysis of the data going through. So for an agency, if they want to.
Yeah, and so a final question here. We have another one from Brian. So Azure DevOps, Azure API Management, Cosmos DB. Would we say that we're heavily cloud locked, or if we were to decide to go to a competing vendor or go back to an on-premise solution?
It's a good question, and one of the other principles I didn't mention was to prevent that we are locking ourselves in. We have selected like Cosmos DB, but it's a document databases, and we could replace it with something else. API management probably will be more difficult, but we are not using so much of the features in API management. It's just a gateway for API, so we could easily, probably with some weeks of work, replace it with another software. So it has been an important requirement for the Norwegian digitalization that we're not locking in on this on Azure, because we are selecting Azure now, and it could be something else in the future. So yeah, it's important for us too.
Yeah, we should get some more data centers in Norway then, I would say, before we could consider them. I think that's about what we have of time. Thanks so much for watching us, guys. Reach out to us on Twitter, LinkedIn, wherever.
And go see our code on GitHub.
Yeah.
Yeah, link is right here.
Make a pull request, please.
Thank you.
I want to start this talk off with a show of, let's say, virtual hands. So, have you ever worked with a React component that was just particularly bad? Have you ever written one? Well, if you didn't at least mentally raise your hand right now, you're not just lying to me, you're lying to yourself. But what is this concept of a bad component? We had this intuition about how it makes us feel, but what specifically made that component you just thought of so bad? I've tried to come up with a few main categories of terribleness. The first and most obvious sinner is when the component's API, its props, it's either too complex to understand, badly named, or a combination of both. If your API doesn't make sense, it's extra frustrating when there's no documentation to explain it to you. Or even worse, if there is some, but it's out of date. If you've been so unfortunate that you've had to fix a bug on one of these bad components, you'll probably turn pale by looking at how it's tested, if it's tested at all. Complex components make for complex testing, which in turn leads you to silently skip that part. And if you're adding a feature or rewriting your components to use hooks, you're probably in for a treat. Hundreds or thousands of lines of code jump at you that you have to change, and making sure it's impossible to do a single character change without breaking at least 20 tests and definitely dropping IE support. What you're left with then is a pretty poor user experience. Not the end user, they might not notice a thing. React is cool like that. But the user that matters in this context is you, the developer. It's important to feel compassion for your fellow developers and write code that they will find easy to work with. So how can we turn this frown upside down? We're going to explore what makes good components good and how you can write React code that your colleagues will love. Code that you will love in a few weeks' time. Oh, by the way, before we get into this, I'm Christopher and I work for Beck here in Oslo, Norway. I've been writing React apps for most of my career, and I can tell you right away that all of the tips that you'll receive in this talk is earned the hard way. My colleagues will probably tell you that I've learned them through repeated failure. First though, I want to dive into this term, compassion. It's one of those words I struggle to define. To me, it's that feeling you get when thinking of how others feel. The most formal definition is co-suffering or feeling for another, but no matter how you word it, it's about putting yourself in somebody else's shoes and envisioning their struggles. Showing an interest in other people's well-being is part of most, if not all, cultures and religions. Understanding how people's struggles and hardships can be a powerful emotion and a catalyst for change. Most people have probably felt some sort of compassion for the situation currently unfolding in the US. We try to understand how African Americans feel when they are being systematically targeted, harassed, and abused. Some help out by donating, spreading the message of equality, or protesting for their cause. But all of this is driven by the compassion for people in a hard situation. But how does this all translate? How do we apply this very, very emotion-driven concept of compassion to React? Well, my claim is that code is communication. When you write code, you're transmitting your intent to other people or your future self. The people reading your code want to understand you, but for optimizing this communication flow, it's something that we rarely do explicitly. Again, leading to intent being lost in the translation. The componentization of front-end code is making collaboration easier than ever. You can create custom hooks and complete UI pieces and ship them off as an NPM package in minutes. That also puts an added importance on this developer-to-developer communication. How do you onboard users to your open source library, for example? How do you make them feel it's a good library to use? The way we communicate is different from our day-to-day communication too, because instead of words and body language like we are doing now, now we communicate through props and docs and test cases. Writing code that other people will love to use, work with, and extend is hard, but it's what I call compassionate. And creating components that takes other people's needs and wants into consideration, that's what I call compassionate components. So, so how do we get there? How do we show compassion to our fellow developers through our React code? Well, first we need to figure out what makes good components good, and in many cases, it's the opposite of what makes them bad. So, first, you want to create explicit and extendable props that are both intuitive and easy to use. You want to write extensive documentation that is easily accessible when you need it, and use tools and write tests that give you real confidence in your code. It doesn't get in the way of writing or refactoring it. Write code that is easy to extend with new features as well, while still maintaining all the other traits of a good component. And those are the topics we'll discuss in this talk. Props. Back in the 90s, props were something people gave you when you looked particularly fly. Today, we use the term to indicate that data and functions we send to our React components. Perhaps not as fly, but I digress. These props is the interface of our component. This is how we interact with it, or put in another way, it's the API of our component. We pass data in and we expect a result to show up in our browser or mobile app. So how do we create a nice API for our components? Are there any rules or prior art we can lean on here, or do we have to figure out what's important from scratch? Now, API design is not a new term. We've all probably heard it before. It's probably decades old. But we typically think of API design in connection to REST and SOAP APIs or some other data transferring stuff. But as it turns out, API design can be just as much about how you structure your interfaces between your components. When I did the research for this talk, I read some prior art on what people would consider good API traits, and we found a few things that most people agreed on. First of all is versioning, because stability is key. The more churn you have in your APIs, the more pissed off your users will be, because their intuition is broken, and they need to learn the new API and unlearn the old one. Make sure you have as few breaking changes in your APIs as possible and keep each one as small as possible. Error messages, they're incredibly important because when there's an error, good information is key to fix it. So help users fix the problem instead of blaming them for doing something wrong. Developers are flimsy beings and they don't like surprises. So make your API intuitive by following the best practices and naming conventions that apply to you. And most importantly, do things the same way across all of your APIs. And finally, minimize your API surface. The less surface your API has, the less the user has to learn. Expose only what you know that your users will need, and only when they need it. Now, these are good guidelines for REST APIs, but it sure seems like they would translate well for React components as well, right? So based on this insight and about 6 years of experience, here are my favorite techniques when designing the props of my components. First, I like to avoid Boolean props if at all possible. A Boolean is absolute in its very nature, and it doesn't lend itself to making extendable interfaces. Let me explain with an example. When you're creating your new fancy button, you might want to create different variants of it. Let's say you have a base version without any styling at all, and a primary button that you use for the really important stuff, like signing people in. Since JSX has this really nice syntax for Boolean props where you can skip using the value, you'll just write a primary prop, which turns your button bright and attention-seeking in no time at all. A few weeks later, you're creating a new landing page, and those attention-seeking primary buttons needs a toned-down sibling. So you add a secondary prop, which magically makes all your buttons a bit more laid back. Still, we're all good. At some point, though, you're asked to add the CTA variant by the sales team, since CTA, or call to action, button needs to blink or whatever they do to make sure people buy your stuff. And this starts to complicate things because you're now pulling in a new naming category or strategy. Could a button be both primary and a CTA? You don't know. But you now have primary buttons and secondary buttons and CTA buttons. But technically, you can have all three simultaneously. There's nothing that stops you from doing this, at least not technically. And even if you know that the CTA button and primary button are two props that are mutually exclusive, the next developer to join our team might not. Instead, I suggest you use enumerated values in a string, like variant here. Later, if you want to add new variants, you don't have to expand the API with a new prop, just a new available enum value for the already existing one. This makes sure you don't allow for impossible states too, so it's a double win. That being said, sometimes Boolean props are the right tool for the job. Sometimes things are just true or false, and the concepts they describe isn't an expandable one. Whether the button is disabled or whether it's in a loading state or not, those could still be valid use cases. Just think twice before you decide on using a Boolean prop, because more often than not, you should be using enumerated values instead. One of my favorite things about React is how it makes it easy to compose huge apps from tiny building blocks or components, each with its own responsibility, UI, and interface. You should take advantage of this part of React. Make components that compose together. I'll explain with an example. Let's look at a modal component. Now, I know a lot of people aren't huge fans of this particular piece of UI, but I've encountered it enough times that I know it might be relatable. They often end up requiring tons of props though, since there are so many variations we need to cater to. Now, this is just a tiny fraction of what you'll see in complete modal libraries, and the list goes on and on. To me, understanding and learning this huge API is a really hard task, and I'd rather just not. It's not a very compassionate thing to ask your consumers to deal with, in my opinion. Instead, we can break things up into a modal's unique parts. And it has a few of them. The overlay, the faded out background, the white content box on top of it, the close button, perhaps a title, a content holder, and perhaps even a footer with some action buttons on it. And by creating small components that combine together to create something, you have the flexibility to create exactly what you want, if you want something out of the ordinary. Perhaps we wanted a version without a close button, or perhaps we don't have a meaningful title, or perhaps we wanted a pink overlay today. The downside of this is, of course, that this flexibility is a huge overkill like most of the time. Most people use complex components in the exact same way. Giving them this huge API is just going to be in the way or create a ton of tiny design variations, which we don't really want either. But what's stopping us from having both? Luckily, there's nothing stopping us from creating another component that just does all this boilerplate for us and combining all of these composable components in a predefined way. These components can cater to the 90 to 95% of use cases where we want a default layout or default behavior. And if you want something special, you can always break it down to the more basic pieces and roll your own. This is a great technique for a lot of different components, from buttons and drop-downs to product presentations and site layouts. My third rule of thumb when it comes to components and their APIs is to make sure I allow for semantics. When it comes to creating reusable components, you'll never have a guarantee or the full picture for what context they'll be put into. We could use divs to create all of our elements, I guess, but by doing that, we'll lose all the semantic structuring possibilities we get by using HTML to its full potential. So, how can we allow for semantics? Take this card component. It's a box that might have an image and definitely some content. There's no real semantics to a card, at least a generic one like this, but the way it's used might vary. Here, we might assume it's a div, but it could also be a part of a list and be a list item if bunched together with a lot of other cards. We could, of course, create two very similar components, like a div card or base card and a list item card, but that leads to a lot of code duplication and potential future bugs. So luckily, there's another way. By providing an as prop, we can allow the developer to decide the correct element based on the context it's in. This can be even more powerful too. You can send in other components that render your component. Think of your favorite routing library's link component, like React Router's link. We can make our card into a link card in a few characters of code. But how can we implement this? Here is a super basic implementation of a card component. It renders a div with a card class on it, and that's about it. So let's introduce that new as prop. Here, we rename the as prop to element with a capital E. This is done so that we can override what DOM element is rendered by our component. Note that if we don't pass in an as prop, we'll default to a div. We can also do this by deconstructing the props directly in the argument list, complete with renaming and providing a default value. Now, I know the syntax is trash, but it's one of those things you get comfortable with really quick for some reason. Now our component is completely adaptable to whatever context you put it in. And you can do the same with all kinds of elements. Cards can become whatever you want. Some buttons might need to be links instead. Your grid system might provide some extra content hints by using sections or articles in the right places. And you can create truly basic components that can be composed together with all the semantic meaning you need. You might have noticed, though, that my last example was somewhat flawed. I made my card into a link and provided it with a to prop to indicate where it should link to. But that prop was never applied anywhere. It just was forgotten about, so that wouldn't work. And think about more generic components like buttons or input fields. Do you even know half the available HTML attributes for an input field? I don't, and I don't have to. Thanks to my next tip, spread the remaining props. Since we're talking about our previous example, let's go back and fix it. We first collect all the remaining props from our destructuring assignment and use the rest operator to place them in an object we call rest. Next, we spread those props on our root element with the spread operator, like so. There's one more thing to do though, because if you paid attention here as well, you might have noticed that I introduced a new bug right now. If the developer passes a class name, it will override the existing card class. And that's probably not what I want. I wanted to extend my component, not just override stuff. So to fix this, I pick out the class name prop from the props object so that it's not in the rest object. I end up spreading out. I give it a default value of an empty string, and then I concatenate it together with the existing class prop. And there you have it. Now we can pass in whatever props we want without getting into trouble. The technique works really well with the spreading of props, but it comes with a few caveats though. First, you always need to remember to combine any internal props you're adding to your component. So if you add an internal onClick handler, make sure you allow the user to send in its own onClick handler as well, and then you need to remember to call both of them. Second, if you can't combine props, you have to decide whether people should be able to override your props or if you should override theirs. And that kind of depends on the use case and mostly personal preference, to be honest with you. I like to let the end user to decide as much as possible, but that's always up to you and the situation. And third, this works best for components with a single DOM node, so it's easy to understand where the props will be placed. There are some exceptions, of course, but complex components often lead to misunderstandings and hard to understand APIs. But with these caveats in mind, though, you should remember to spread the remaining props wherever you can. Whenever you're designing a component, it's easy to get creative with the props naming. Those HTML attributes from the 1990s are so hard to type, and they often could have had better names, I guess. But I urge you, avoid renaming existing DOM attributes in your props. I'll show you why through an example. At a previous project, we created the almighty button component. It was flexible and nice looking, and lots of people used it throughout the organization. There was a few different types of buttons though, like a primary and a secondary button, and we used the type prop to specify what type of button it was. And this worked out well too, up until one developer placed a few buttons next to each other inside of a form. It turns out there is a native type prop or type attribute on the button element, which takes a value of either submit, button, or reset. And the default is submit. So when a button has a type of submit, it triggers the form's onSubmit function. And we didn't want that to happen in our particular use case. We wanted nothing to happen except the onClick event. Since we spread the props though, we didn't have a way to set both that we wanted the button to be a primary and to be a regular button. There were tons of people using our button throughout the organization, and since we didn't want to create a huge break and change for people, we did a huge mistake and introduced the button type prop. Now, this solved our problem at hand, but it created a terrible API. And even if you knew the backstory to it, it made sense, but new developers that joined the organization understood nothing. They thought we were terrible developers, which in hindsight, I guess we were. So learn from our mistakes back then and never override an existing DOM attribute with a prop name. Even if it's esoteric and you probably won't even care about it, but just come up with another name instead. Like this API, for example, which is much easier to understand. And this goes on for tons of other types of props too. I see, for example, renaming DOM props a lot when it comes to area attributes. Like instead of just writing out area busy like a normal person would, you might write is loading or area busy in camel case. And this leads to a lot of variations across your code base probably because different people come up with different naming strategies. So it could be loading, is loading, lasted in Norwegian, or it could be a ton of different stuff. And all of that makes it hard to intuitively guess the API of your component and other components in your score of components. So instead, take advantage of the fact that you're spreading your props already. This way, you don't have to come up with names, first of all, and you don't have to write a prop type or typing for it. You don't have to add a new prop for every new area or DOM attribute that you or your consumers can think of. That's a bonus. This provides you with a small yet well-defined API that is flexible enough to rarely change at all. These 5 rules of thumb will help you create components that are easy to understand, easy to use, and easy to extend, and even easy to like. But the most important takeaway from this section is that you should design your API and don't let it be a coincidence. Design the props of your component so that they're easy for the next developer to understand and extend if they need to. The next thing I want to talk about is documentation. And documentation is a loaded word, I know. It's filled with the memories of the stuff you wrote into Confluence once and nobody ever saw again. And most of us are probably filled with bad experiences with documentation too, because it's tedious to write, nobody ever reads it, and if somebody does stumble across it, you know it's outdated. But have you ever experienced amazing docs? When done right, documentation can be a joy, both to write and to consume. Great documentation is always easily available, and available right when you need it, where you need it. Great docs are always up to date, even with that latest feature that you just shipped. And lastly, great documentation makes it easier for other developers or even future you to understand how your code works, which in turn speeds up development time and cuts down on cursing. So let's look at some ways we can make our code more readable and understandable through documentation. The most important part of documentation to me is that the documentation shows up whenever I need it. Whenever I hover a component or type it in and autocomplete it, I want the editor to tell me all I need to know. Turns out doing this today is pretty simple. JSDoc is a way of writing comments that is easily parsable by our editor, which will show whenever you hover a component or a prop or a custom hook or a function or a whatever really. And here is what it looks like. You start a block comment with 2 stars instead of 1, and you're in JS doc mode. Here, I've added some docs to our card component from earlier. You can write long paragraphs if you want, but a simple explanation of the what, the how, and the why usually suffices. You can even add examples. These will show up and can be great to show both simple and more advanced usages of your components. And in VS Code, at least, you even get syntax highlighting. You can also document your props, complete with deprecation warnings and aliases. And each of these prop comments will show up whenever I autocomplete any of the props on that component. And that is incredibly useful. Not only does it show up just in time so I can learn just in time, but since it's co-located with your code, it should never get out of date. And it also documents your code for future maintainers. There is a lot of features in JS doc, and I recommend you give it a shot. Here's a great resource. I used to remember what the different keywords mean, but it also autocompletes in your editor. And don't worry about writing this down. I'll post the slides after. Sometimes you want a documentation website for devs to visit. You see this a lot with component libraries or design systems. I've made a few. You want a bit more prose about what to do and what to avoid, and you definitely want some nice interactive examples to play with. There's a few tools you can use to create stuff like that today, but my favorite is by far the Gatsby-based tool Docs. Docs is a single dependency and gives you basically all you need out of the box. It gives you a live playground editor, hot reloading for development, it parses your props and documents them for you, and it gives you a themable and pluggable design that you can customize to whatever degree you want. It works by scanning your repository or folders for JSX-enabled Markdown files and creating a statically generated website you can host wherever. That means you can co-locate your Markdown documentation with your code as well. Another added bonus is that it parses your JS doc comments and shows your inline code comments in an easy-to-read format on the web. This is a huge bonus because it means that you, in order to be both on the web and be documented in the code, you need no documentation duplication whatsoever. This is how it looks by default, by the way. It even ships with dark mode if you want that. It's a great way to create more in-depth documentation too, which can come in handy for some of the more advanced components you put together. Another way of documenting your code is creating really good error messages and warnings that show up in the console while developing. This comes with a few upsides. First of all, it helps people new to your code base to use your code correctly. So if they consume a context without wrapping your app in the correct provider, or if they've passed in an illegal combination of props, or if they're using a deprecated feature, they can be told why stuff doesn't work in full sentences. Perhaps you can even link to a custom page in your docs documentation website that goes into more detail about what one should do and how you solve deprecations, for example. The second nice thing about dev-only warnings is that they live with your code. They are code, I guess. So code doesn't get outdated the way documentation does. It gets removed or refactored away. So thus, the warnings are never out of date. People reading the code can understand why something goes wrong, which is also a huge plus. Finally, if we're worried about the bytes here, you can tree shake all of these warnings out when you're building for production. That means 0 added bytes to your app. You get a much better user experience for the developers. Documentation is key, and it doesn't have to be boring. It doesn't have to be outdated, and it doesn't have to be left unread. Focus on placing most of your documentation inside of your component files, next to your code. Use JSDoc to integrate it with your editor. Use Docs to create interactive documentation websites. Use dev-only warnings to document edge cases, deprecations, and misuse. And remember to link to relevant documentation sites in your dev-only warnings as well. The end result is that your colleagues will love reading your code, You put their need for information first while providing it to them just in time. So, we've learned some ways to create well-crafted props for our components and looked at how we can document their usage. The last part of the puzzle to create truly compassionate components, at least to me, is to build trust. We need to trust our components. But what does it mean to trust your components? In my eyes, you need to be confident that the components works as intended. And that means no bugs, edge cases covered, it's both usable, it's accessible, and I can test the component and all its test cases manually, but I'd rather have software do it. Also, you need to have a strong sense of confidence if you're ever to refactor your code. Again, you could solve this by full regression tests all the time, but those they're expensive and impractical. So we need to be confident that we've done a good job implementing stuff before we ship it to our users. But what's the best way to get there? Writing tests for front-end code used to be a nightmare. There was shared state a lot of times between the tests. The feedback loop was always really, really long. And people wrote an amazing amount of unit tests. Today, the situation is pretty different. We have tools that help us write better code. The test runners have become much more developer-friendly. But we still tend to test implementation details through a lot of these unit tests. In this last section, we'll look at how you can build trust in your components while not getting in the way of a good developer experience. There are lots of problems that we can use existing tooling to find and report for us. I mean, us as developers, we're obviously pretty smart, but machines can be pretty clever too. If a program can analyze our code and find bugs for us, we can do more useful stuff with our time. The most popular tool for analyzing our code these days is ESLint. And a linter like ESLint can spot pretty advanced bugs and fix them sometimes. It could find potentially infinite loops, or it could find like a missing dependency in your use effect, or a missing area label in your icon buttons, for example, or just code smells in general. There are tons of ways to set up ESLint, but the defaults that ship with Create React App is usually more than enough. If you're not using Create React App for your app, you can use its predefined rules with extending their config in your ESLint config, and then just add or remove whatever you don't like. ESLint has saved me from shipping so many errors, and it helps you avoiding testing the kind of bugs that they fix. There's another type of static analysis which is particularly helpful when creating React applications, and that's static type systems. As you probably know, JavaScript is a dynamic language with no built-in type system. This provides us with a lot of flexibility when it comes to solving challenges, but it also doesn't provide any safety net at all. That worked back in the days when you only had to do a few minor things in JavaScript, but in today's application world, that's kind of not good enough. The result is that we have to ensure our code can handle whatever input we throw at it, leading to the need for lots and lots of unit tests, which in turn sucks. Instead, we can use type systems like TypeScript or Flow, or more likely TypeScript, to type our interfaces. Here's an example of the props passed to our button component earlier. We can specify the type of arguments and check that the code calling our components are doing it correctly. Compile time. And this way, there's no way to misuse the API and to get a really nice and tight feedback loop. And a little side note, TypeScript or Flow used to be really hard with React, but in modern React with custom hooks and stuff like that, it's really as easy as you can think of. I was super afraid of it, and it turned out to be really, really nice. So if you haven't given it a shot, give it a shot. There's actually tons of potential upsides to use in using a type system like TypeScript in your code right now. I won't go through them all in detail. It's an hour-long talk in itself. But my favorite ones are that it's much easier to discover what's available in an API because you get this great auto discovery and auto completion. It also replaces most of your unit tests with actual code. And finally, it makes refactoring so much easier because you can programmatically refactor stuff without having to remember all of the stuff that you need to change the name of. So consider introducing types to your code base. You can do it gradually if you want, and there are tons of great resources out there to get you started. Another thing I want you to remember about testing your React components is that you should avoid testing implementation details and test the stuff like your users use your component. By doing this, you'll have much more sturdy unit tests, which won't break whenever you do a refactor. And you'll test that stuff will work for your actual users and not just in your test suite. But how do you do that? Well, first off, I suggest you throw away whatever you're using today and start using React testing library. It's made by the testing wizard of Oz, Ken C. Dodds, and it helps you interact with your code like your users do. Next, you should test your components only through their props. By that I mean never manipulate internal state or call instance methods on class components. Instead, just re-render your app with different props and verify that the right things are rendered. And finally, you should assert that your components work by asserting on visible output rather than class names or IDs. React Testing Library has a ton of great selectors to do this for you. And as a bonus, you can actually use accessible selectors to improve the accessibility of your code as well, through getting stuff by role, to remember that you have to have different area roles, for example. Finally, I want to suggest that you try to write broad tests that covers most of your components. If you're testing on an app level, aim for writing integration tests that tests complete vertices of your app. By doing this, you can write much less tests. A few tests will cover huge parts of your code and provide important documentation of happy cases, edge cases, and errorness cases. So these are some of my best tips when it comes to making both yourself, future developers, and consumers trust your components. And trust is important when you're building code other people will use. Without it, we second guess every decision made, even if they were made for a particular reason. To me, code is communication. Code is the language we speak with our fellow developers and the way we communicate our intent. So if you don't remember to communicate in a compassionate way, considering the needs of the recipient, we'll end up writing code that's hard to understand, tricky to extend, and often end up being replaced in the long run. Instead, I suggest that you'll consider some of the tips in this talk to improve that communication. First of all, you need to put some thought into how you structure the props of your components. This will help make your components intuitive to use while making them easy to extend. Creating a good set of props doesn't even need to be that hard if you just follow a few simple guidelines in some talk. You need to create documentation that shows up when you need it. This will make your components much more usable by the end user. In addition, it will help future maintainers, and that includes you, to understand your code better. Use static analysis for what it's worth. You can do a lot less testing by just adding a linter and a type system, and a lot less writing at that. Providing a type system is a particularly helpful way of avoiding bugs while improving API discoverability as well. And when you test, make sure to write wide-reaching tests that use your code like your users do. This provides you with a lot of confidence when you refactor or otherwise change your code in some way. In addition, you don't have to do a lot of manual testing before you go into production. And finally, take a big step back. Try to envision other developers using your code, because when you empathize with their needs and wants, you're showing them compassion. And when you make sure you code for other people, those other people will end up loving your code. That is my talk. thanks a ton for watching. I'll be in the Slack channel answering all your questions if you have any.
What you're listening to right now is the Iliac Suite for String Quartet. And this was the first ever piece of music to be written by a computer. And it was written by this computer. This doesn't look like a computer you usually see because this is a mechanical computer. And Larry John Hiller used this computer to compose the piece of music that we just heard. This was something he started in the mid-50s, and it took him a few good years to complete. So ladies and gentlemen, welcome. At this time at the NDC is where everyone would be starting to look forward to the legendary NDC party. Unfortunately, this year we won't have an NDC party, and there won't be any Dylan Betty-led NDC band to play you music. But I'm here, and I'm going to take you along on a journey through the history of computer-played music. And by that I mean music that was played by computers. So my name is Anders Norris, and I'm going to take you on a journey. So welcome along. And this is a journey that starts in one of the countries where NDC has one of their conferences. And no, it's not America. This is a story that starts in Australia. What you're seeing right now is the Syserac computer. And the Syserac computer was one of the few computers around in the world after the Second World War, when people realized that computers were a smart thing to have. Now, this computer didn't have that regular user interface that you're used to, but it had a small speaker connected to it, so that the engineers operating the computer could hear a small little beep, beep, whenever the computer was finished processing something or running a program. Now, one of the engineers working with this realized that he can modulate the signal going to this little speaker, and using that, he managed to program the first ever piece of music to be played by a computer. So this is Colonel Boogie's March, and it's marching band music. Now, this kind of music was really popular at the turn of the 19th century. All over the world, actually, not only in Germany. And this was one of the songs that he chose to program. So this piece of marching band music was the first ever to be played by computers. And as I said, this didn't start in America, but Americans were far behind. And whenever things were happening in America at this time, it was happening at Bell Laboratories. So in 1957, an engineer at Bell Laboratories was working on the IBM 704 mainframe computer. And what it was working on was making that computer able to make sounds, which is kind of an obvious thing to do when you're a telephone company. Now, he was working together with Newman Gutman, and together they created the first ever DSL, or at least the first ever computer-based DSL for creating music. Because if you think about it, whenever we speak about domain-specific languages, or what's known as DSLs, we always come back to referencing sheet music. Because if you know how to read sheet music, you can play just about everything. And one of the things you could play if you knew how to read sheet music, or the Music 1 programming language, is this little piece of music called Silver Scales. So, Silver Scales was actually the first ever piece of music to be released on a vinyl album. And what you're seeing right now is that very vinyl album. It's called Music for Mathematics, and it was released by Decca a few years after Max Matthews programmed this piece of music. And this was a sort of music concrete, and that takes us to Putney in England.
Putney, where Peter Zinoviev has a hobby which is strictly for boffins. He keeps it in his garden shed, and it's called Digital PDP 8/S. Yes, it's a computer, and it has a hobby too, composing music. Peter helps with the ideas, but the actual performance is all Digital's work.
So, the Brit, Peter Zinoviev, having quite a bit of kit in his garden shed, started experimenting with electronic music in the mid-60s. And he had these two Digital PDP/8 12-bit microcomputers. And for that, he created his own programming language that was based on the Digital PDP macro assembler. And he called that Musis. And you see the code for it right now. It's not music as you're used to, but this resembles something related to music. You play a note with the note command, and then you have a duration and you have a pitch and so forth for the note. And this he combined together in small little pieces of code that performed music. And this was as experimental as the code you're seeing right now. And he took this with him to the Queen Elizabeth Hall for a performance of this kind of music.
The next item, Partita for Unattended Computer by Peter Zinoviev, is a true live performance in the sense that no magnetic tape is being used at all. Furthermore, the computer has a choice at various stages in the procedure, and the piece therefore comes out different every time it's played. The performance you're about to hear is therefore unique and unrepeatable. First of all, checks are made to see that the composition is correctly loaded into the computer. The computer is started and will carry out the performance unattended.
So a nice piece of proto-techno music going on right here. And this was recorded at the Queen Elizabeth Hall in January 1968 in London. And the Queen Elizabeth Hall is just whereby NDC London first was hosted. So this is a bit of NDC history as well going on here. Now, Peter Zinoviev's piece, Partita for Unattended Computer, was special in that no tape was being used, as they said in this presentation of the work. And this computer was actually playing that piece of music live on stage. And that was the first time that ever happened. So this was a landmark event. And the press weren't that impressed by this. The Times wrote, technically it may be a triumph of skill and knowledge, but what we heard resembled the dreariest kind of neo-weapon drawn out to inordinate length. Now for the less cultured among you out there, neo-weapon is in relation to the Austrian composer Anton von Webern, who created atonal music. But even if the mainstream media weren't really impressed by this, the specific journals writing about computers, such as Wireless World and Computer Weekly, were enraged about this, and they wrote pages upon pages about this performance. So this is a landmark event in computer music history. But we have to go back to the Bell Laboratories to really see the big landmark events of the 1960s. And we're back with the IBM 704 computer. And way back, before Peter Zinoviev did his thing, in 1961, programmers at Bell Laboratories were experimenting with making computers talk in a voice recognizable by humans. And these two people here, John Kelly and Carol Lochbaum, did something amazing. But it's mostly thanks to Carol in front here, sitting there programming the IBM 704 computer, because she painstakingly programmed in the song A Bicycle Built for Two, every single vowel by vowel, and it sounded like this.
Daisy, Daisy, give me your answer too. I'm half crazy, all for the love of you. It won't be a stylish marriage, I can't afford a carriage, but you look sweet upon the seat of a bicycle built for two.
beautiful piece of music, a bicycle built for two. And of course, the music here was programmed by none other than Max Matthews, which we've met a bit earlier. Now, some of you might have recognized this music as something you have heard before, and this is the reason why.
Yes, I'd like to hear it, Hal. Sing it for me.
It's called Daisy. 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 Give me your answer, do. I'm half crazy. All for the love of you. It won't be a stylish marriage.
So one of the most iconic death scenes in one of the most iconic films with one of the most iconic computers in all of film history has a reference to this piece of music where you first ever heard a computer sing. Now, if 2001 wasn't a beautiful film already, it's now going to be forever and ever. And this film is from 1969, the final year of the 60s, and that brings us over to the heyday of the 1970s and where computer music started to take off for real. Now, this is a classic game. This is Space Invaders, and you might not think of the soundtrack in Space Invaders as music, but if you listen, you have those 4 bass notes going down and down and down. That's a piece of music. And Space Invaders was the first ever game to feature music used in a way to elicit a response from the player. Because as the aliens approach and get closer and closer to your little spaceship, the music is going to go faster and faster and become more and more intense, causing you to lose some of your concentration and finally kill yourself so that you have to put in another quarter and play it all over again. So this little simple piece of music is an example of how music was used in video games and has been used forever and ever after to elicit a response from you as a player. Just a few years later though, music in video games was something totally different. And this is the game Rally X. And this featured music by Kazu Kusuru. And he wrote down every single note for the programmer to painstakingly programming hexadecimal machine language code into the game. But it resulted in a kind of funky soundtrack, and you have that sound that is going to be genre defining for what is going to be known as chip music later. And incidentally, we recently saw the first piece of music to be released on vinyl, being computer music. This is the first ever video game soundtrack to be released on a vinyl soundtrack as well, and that happened 6 years after the game came out in 1984 on Japanese imprint Yen Records. But you didn't only have vinyl records to take computer music into your home. You also had this, the iconic Atari 2600. And this game is called The Music Machine. Why not? It's a talk about computer music. Now this is a rather rare game. It was only sold in Christian bookstores, but it has that little soundtrack at the beginning. And it's amazing that they were able to create this kind of music with this simple machine. Because this had a 5-bit pitch. That means that it had 32 different tones it could play. Tones, not notes. And the frequencies were sort of influenced by the synchronization signal of the television it was connected to. So everything was a bit out of tune, and it had limited sort of waveforms it could create. So even if this sounded really simple, it's really amazing that one were able to create this kind of music. But obviously, people deserved something better.
lets you play hundreds more games than any video machine, plus draw, program, even do music. I'm more alive than ever before, and my friends are knocking down my door. 'Cause now we're into so much more. We're into our Commodore 64.
Yes, the legendary Commodore 64 with the legendary Most Technologies 6581 sound processor in this. And the designer of this chip, Robert Jans, said that he thought the sound chips on the market, including those in Atari computers, were primitive and obviously had been designed by people who knew nothing about music. And he wanted to change that with the design of this. Now, this one was originally designed to have 32 channels. Now, it only ended up having 3 in the Commodore 64, but it's still designed for those 32 channels. And what you can do, if you have a few Commodore 64s laying around, you can actually open them up, take out these processors and stack them on top to get more channels than it originally had. So this is a legendary piece of musical hardware, and it gave us sounds like this. And just listen to this. This is Mule by Electronic Arts from 1983, one of the first games to be released for the Commodore 64. Now the soundtrack here is entirely different from what the Atari 2600 had brought, but this is actually quite simple compared to what happened a few years later. With legendary soundtracks like this one, Commando from 1985 by Rob Hubbard. And just look at the oscilloscopes here. There is so much going on. And that is why, because Rob Hubbard and other musicians using the Commodore 64 realized that you could play around with the different sound channels on the Commodore 64 and tweak the sounds. And for any of you who have ever touched a real live synthesizer, you know that the magic happens when you twist the knobs around to get that fat, funky, fresh sound out of it. So this one is amazing. So why does Nintendo from the same year sound like this? Due respect to Koji Kondo, but this doesn't sound nearly as funky as the Commodore 64 music, and the reason is this. If you look at the oscilloscopes here, Nintendo had made some choices for their musicians that it would have 2 square waves, 1 triangle wave, and 1 noise wave, and this was all you had. And the reason for this is why all Nintendo games sound mostly the same. You also had a sample channel that you could use, but the Nintendo cartridges didn't really have space to have samples, so that mostly was left unused. So the Commodore 64 was the master at the time. So much that in 1999, the Swedish synth producer Electron bought up the entire surplus stock of SID sound chips and created this little beauty called the SID Station. And this is a synthesizer that gives you the original classic sound of the Commodore 64. And if you've heard music by Daft Punk or the Swedish pop star Robin or Norwegian electronica pioneers Röyksopp, you've heard this. Because this is the flip side to Röyksopp's first ever 7-inch single. And this is where they pay homage to their origins and where they came from. This is made with the sounds of the Commodore 64, and this is the beautiful, very rare and unknown Röyksopp song, the 64 Position. But it has that sound. And it has that funky sound chip groove that we know as chip music these days. So those guys in Röyksopp knew where they were coming from. And the Commodore 64 opened up the possibility for people to use their computer to make music in an entirely different way. Now this gentleman on the photo here is Chris Hillsbeck, age 17 in 1985. And that year, he won a competition in a German computer magazine where he created this piece of music called Shades. The year after, he created this piece of software called the Sound Monitor, which was a domain-specific language for writing music for the Commodore SID chip. Now, this took a step away from the music software that had been available before that allowed you to use classical musical notation to create your music, and instead you wrote your music with hexadecimal codes and so forth, using the language of the computer instead of the language of music. And Chris Hülsbeck started a trend with this that was carried further with this young gentleman. This is Jochen Hippel, a few years later, working on the Atari ST computer. And I got fooled by Atari's marketing to get myself an Atari ST because it had this Yamaha sound processor in it. And Yamaha is my favorite combined motorcycle and synthesizer producer. So I got this one. It turns out that this chip was a off-the-shelf generic sound processor just produced on license by Yamaha. And it was rather primitive compared to the Commodore 64, but Jochen Hippel, inspired by the music created on the Commodore 64, pushed this to the limits and created this sort of music, but carrying forward the music of Chris Hülsbeck and the other pioneers on the Commodore 64. But where the action was really at these days was on this computer. And it's of course the classic Commodore Amiga. Now, we've all heard the stories about how Steve Jobs allowed his engineers to sign the inside of the Macintosh computer case. Now, Jay Miner, the manager at Commodore, he was way ahead of Steve Jobs. He allowed his engineers to name their chips after their second others. And this here is the Pola music processor in the Commodore Amiga. And just listen to this piece of music by Danish composer Jesper Kyd. It's entirely different from what we had on the other computer. And this is the Fast Tracker computer software that built on the Soundtracker concept that Carson Oblosky introduced in 1987 and has been used in many different ways to change music production ever since. But before we leave the Amiga entirely, we have to see where the geniuses of Chris Hülsbeck and Jochen Hippel meets. Because this is the classic game Turrican 2. And if you listen real closely, there is a really rich, full soundtrack here. And that is because this one has 7 voices, and that's more than the 4 voices that Commodore Amiga actually had. Because this is where the teenage engineering geniuses of these two guys meet, where Chris Hülsbeck uses the algorithms that Jochen Hippel came up with for the Atari ST to be able to mix as many soundtracks as they want together and really use the computer as a composing device. And these are a few 12 inches from my own collection, and I'm going to let someone else tell you the story about Norwegian musician Erot, because his story is worth telling.
You would be correct to call those records seminal that he made, because listen to them.
People should be aware of the equipment he used to make those records. People would laugh now. Your phone is more powerful.
The stuff he did freed a lot of producers from what they believed was right and wrong. Producers like him is really necessary for music to grow.
Yes, Battlestar XB7 by Erot. And this musician created music on his PC using Fast Tracker software, and he changed the Norwegian new disco scene forever. So if it hadn't been for Erot, we wouldn't have the entire wave of Norwegian musicians, and he created this with minimal equipment in his bedroom. Thank you. But minimal equipment could actually also produce proper pop music. And this is Calvin Harris from his debut album from 2007. And he didn't have much gear at that time either, because he hadn't become a famous producer yet. So he created the entire album using a Amiga 1200 computer and tracker software. So So this is legendary software. So legendary that Polyand, producer of boutique synths, actually released this little beauty earlier this year. And this is a hardware sound tracker. So this is taking the software project that Carson Oblowski started back in the 1980s and putting it back into a hardware package you can use for performance on stage. It's beautiful. But people have been using other kinds of hardware to create music in all sorts of strange ways. Now, this is the MTV music generator for the first original Sony PlayStation. And this was a game, if you can call it that you could use to compose music. And people actually used this to compose music. And this here is the Norwegian band Tøyen, who had a minor hit on national radio in Norway back in the early noughties with this song called India Pindia. But it's not only Tøyen using their PlayStations and taking their PlayStations out to perform live on stage on tour using game equipment to create music. Loads of people have used the Game Boy and still use the Game Boy to create music. And the band Anagmaguchi actually created the soundtrack for Scott Pilgrim vs. the World in 2010, and it reached number 3 in the Billboard charts with music created on the Game Boy. Also, behind the alias Dr. Spin, who had a big top 10 hit in the UK in 1992 with the soundtrack for Tetris remixed in the dance version, hides the famous name Andrew Lloyd Webber. So computer music has been created by loads of people in loads of different ways. And it's still being used, and it's good fun to see people playing a Game Boy on stage.
Planet Earth, a scientist creates the ultimate machine.
At last!
A machine that will give him the power to journey into the mega world. With thousands of colors, 16-bit graphic technology, and 10-channel mega stereo sound.
Stereo sound.
The most advanced video game system in the universe.
Yes!
Mega Drive from Sega.
The Sega Mega Drive. And why this is important is because of this little beauty here. This is another Yamaha sound chip, but compared to the one in the Atari ST, this one is an actual legend. And you've all heard this one, because this one is the one that is sat inside the Yamaha DX7 synthesizer. And that is the synthesizer that Aha play on their blockbuster hit, Take On Me. So suddenly, computer game musicians had this beauty. The Yamaha sound chip that was responsible for one of the biggest pop hits ever to play around with. And boy, did they create. They created lots of great music, such as this music for Street Fighter II, which is really a good piece of music to create a backstory to characters, which is not really easy to do in a fighting game. But Street Fighter is really, really important in other ways, and that is because it had influenced other genres of music entirely.
It's D-Double. Old type swerve on production. It's street fighting time.
Round one, fight!
If it's me or my dad, you get a scar on your chest like Saka. Street fighting, that's what I'm bad at. My thing working perfect. I come through in the beat up under. Give man a 100 slaps like Yonder. Give me the mic and let me ride it with them, cause I spit the fire just like Dalsim.
Dalsim. Yes, this was a piece of hip-hop. This is another piece of jazz. So this is Kamasi Washington Jr., who loved playing Street Fighter when he was a kid, creating his own character soundtrack for Street Fighter. And Street Fighter has had a massive influence on hip-hop. All these artists in some way sampled different parts of Street Fighter music for their songs. And there are loads of famous artists on there. But most important one is maybe Lupe Fiasco, which is another rapper, because Lupe Fiasco went up against the world champion Street Fighter player Daigo Umehara in a tournament match, which Lupe Fiasco ended up winning. And I think that is sort of a manifestation of how much the game Street Fighter has meant to the entire hip-hop genre, where you have subgenres such as the music we heard first, which is entirely based around the themes from the Street Fighter games. So Street Fighter has had such importance for the world. This is the game Wing Commander. And when you have a cinematic intro, like you just saw, you sort of set the bar. And Wing Commander was one of the first ever games to sort of try to create a soundtrack that wasn't just music playing in the background. And what Chris Roberts, who designed this game, wanted to create was sort of a space opera in the style of Star Wars. And you can, if you listen to the music, you sort of hear that influence in there. But what it did was that he created a music engine for his game where the music sort of adapts to the action on screen very subtly. But this was a small start of something big that was about to come. And this one is a classic game. This is Monkey Island 2 using the interactive music streaming engine, also known as iMuse. And iMuse is the result of composer Michael Land's frustration on working on the soundtrack for the first Monkey Island game. Because he really wanted to create music that sort of accented the gameplay. And he did that here. So when you hear or see Guybrush Threepwood walking around Scab Island here, you can listen and hear the music adapt as he moves along and around the island. And this was sort of one of the first times that music was really used as a pit orchestra, in the same way a director directs it at the opera or the theater, to sort of use the music to create even more action in the game. So this was a good period. This was not a good period. This is one of the original Sony PlayStation adverts. And Sony PlayStation was marketed in nightclubs to adults. And that did something about the soundtrack. It had sort of the electronic music of the 90s as a soundtrack. Loads of great music, but rather bad game music. It was a dark age for the game music because this is just background music. It's just score in the background. It has nothing to do with the gameplay. What it did have is that it influenced sort of the sales and saved some of the bands who had albums that didn't sell that well because they could license their music to games, but it wasn't really all that. To get good game music, you need limited hardware, and the Nintendo 64 had that. And the legendary soundtrack for the legendary game GoldenEye 64 sort of has that mashup between John Barry's music, Fate No More's We Care A Lot, and big booming drums. Now, this is on a game console that didn't even have a sound processor. It had to use the main processor to do everything. It did have a DA converter that theoretically had up to 100 sample channels with 28 kilohertz 16-bit sounds, only the cartridges didn't have the possibilities to store that amount of data. So the composers working on this had to revisit the techniques being used in the 1980s and early 1990s by the computer musicians that we met earlier to be able to piece together music in a nice way and create this rather beautiful soundtrack that sets that James Bond atmosphere quite exactly. And another thing that was done on the Nintendo 64 is music for this one, where Koji Kondo introduced algorithmically generated music into the mix. So this is a level known as the Endless Staircase. And it's a staircase, unless you're ready for it, that goes on forever and ever and ever, ever and ever. It just goes up and up. But Koji Kondo uses a musical illusion here, known as the Shepherd scale. Because if you listen to the music, the pitch just keeps going up and up and up and up and up and forever and ever keeps on going up. And it's an auditory illusion where two scales are moving in parallel and it fools your brain. So this is where algorithms came into play. Now, this is the iPhone app, Bloom, which was released in 2008, just after Apple opened the App Store for the iPhone. And this is an app created by the musician Brian Eno. Now, you also see his album Ambient One, Music for Airports from 1978. And this album was where the phenomena known as ambient music started. Now, Brian Eno allowed you to create algorithmically generated music by just touching the screen here. And it's quite soothing, and it has that soundtrack. And Brian Eno actually also created the soundtrack for the game Spore. And if you listen, the music here sounds like the music created by the Bloom app. But this is actually programmed in a visual programming language called Pure Data, which you see here, where you have the possibility to go in and configure different variables, but all of the music you hear is algorithmically generated, and it can adapt to various variables set by the players. Now, one thing about these kinds of soundtracks is that they tend to be like spa music. They tend to be like bad chill-out music. They tend to be a bit boring. And that's a thing that they set out to change with the game No Man's Sky. And the music for No Man's Sky is created by the math rock band 16 Days of Static. Now, No Man's Sky is a universe with 18 quintillion planets that you can visit. And you need an ever-adapting soundtrack to adapt to that endless space. And being a math rock band, 16 Days of Static were used to thinking about algorithms, maths, and those kinds of structures we as programmers think about when they created this soundtrack. So they have loads of different pieces of music they can piece together and sort of create an evocative soundtrack that fits different planets of this universe and adapts seamlessly. But 18 Days of Static creating the music for this game is the first time that proper bands and proper artists have created video game soundtracks. This is the game Quake, and the soundtrack for Quake was created by the industrial rock band 9 Inch Nails. And if you listen to this, you hear that sort of gritty industrial rock sound of 9 Inch Nails, which fits the gameplay perfectly and is a perfect match for Quake. But one thing is that real big artists such as David Bowie also created soundtracks for games. So this is a song by the late great David Bowie from the game Omnicron. And this piece of music is only available in this cutscene, which is deep into the game. And David Bowie also lent his voice to the voiceovers for this game. So there are some rarities by musicians out there that you wouldn't have in your record collection at home. So one obvious one is Michael Jackson's Moonwalker. Now, this is entirely based around the music of Michael Jackson. In hindsight, the idea of having Michael Jackson walking around buildings picking up children wasn't probably the best of ideas, but it's definitely Smooth Criminal that's playing in the background. And Michael Jackson was quite involved with Sega, who released and created this game. But one thing that people don't really know is his involvement in Sonic the Hedgehog games. So this is the music of Sonic 3, Sonic and Knuckles, laid on top of Michael Jackson's song, Stranger in Moscow. And as you can hear, they fit on top of each other perfectly. So, the rumors about Michael Jackson creating the music for Sonic the Hedgehog are actually true. Sonic the Hedgehog came out 2 years prior to Michael Jackson song, and it's very unlikely that it was Michael Jackson copying Sega. Here, he created the music. But he didn't want it released because he didn't really like the lo-fi sound, even in 10-channel mega stereo sound on the Sega Mega Drive. This is one of my all-time favorites. And this sound is really an example of how also early video games could have faithful recreations of soundtracks. This is Mega Blast by Bomb the Bass, which is a sample-based hip-hop game, and David Whittaker has really gone to lengths to recreate the sound of that sort of underground dance hit in the game by the Bitmap Brothers. And with that personal favorite, we'll go into the present time. Because one of the big album releases last summer was a video game soundtrack. This is the video game soundtrack for the game Red Dead Redemption 2. And starting with the first Red Dead Redemption, we saw a change in how music was created. They created tons of tracks in the same tempo, all in the key of A minor, which is a really unforgiving key to play in. That the game engine can mix together, adapting to the gameplay in the manner that Michael Land had started with Monkey Island, but in an entirely new way with natural sounding music played by people, but blending together perfectly, mixed by a computer. And so while we're at Western music, this here is music created entirely by a computer using artificial intelligence. This is a piece of Western music created by OpenAI's MuseNet. And this is a deep neural network that can generate 4-minute musical competitions using 10 different instruments. And it can combine styles like country music to sort of classic 60s style Beatles pop music. It's not programmed to explicitly understand music, but it's programmed to read music and create something that sounds like what it's heard before. Which brings us to this, because this is the band Skygge, and it's a project by Flow Machines, and it's written by an AI, inspired by French pop music from the 1980s. And they also probably got an AI to write the lyrics for this one. It sounds like me, 4 years old, thinking that I was speaking English. It's all gibberish and nonsense. But this is an interesting project. It's inspired by cheesy French pop music from the 1980s. And there are similar projects to the Flow Machines one out there. There's something called Jutec, and Google have their Magenta project. But the reason why people are investing into machines creating pop music, you can see if you look back to the 2008 monster hit by Travis Scott and Drake called Sicko Mode. If you look at the writing credits on that one, you have 30 people credited on the writing credits for that song. And one of the reasons for that is that where the big money in music are these days is in songwriting. And if you can come up with an AI that writes compelling pop hits, you're going to be a very rich person. Yes, a piece of folk music. And as you might have guessed, this is also AI generated. But in comparison to what we heard before from the Muse AI, you know, the country and Western music we heard, is that this is actually played by humans. But it's written by a computer, and it's written by a project called Folk RRN. It's a recurrent neural network, But what's interesting here is that this actually works out pretty well. It sounds like believable folk music. And one of the reasons for this is that in the tradition of folk musicians, musicians have heard something that someone else has been playing and played their own interpretation of that. And in that way, music has evolved and moved from player to player, and new songs have emerged. And that is the very same way that AI learns how to create music. So AI writing folk music is just a logical progression of how folk music has always been written. But it was played by people, and people add a bit of feeling to this.
Machines are making most of the music now. Have you noticed that? Have you noticed that all the songs sound the same? I mean, I don't know if you've noticed that. I mean, I mean, you could be hearing one song. I mean, you could take the lyrics from another song and put it right onto, because the rhythms are the same. You know, the drum and the drones are the same, and the machines can only do so much. You know, they can only make it sound different so many different kinds of ways. So it doesn't sound different. It sounds all the same. And that's good for the industry because a lot of people invent these machines and need, you know, and sell these machines. Plus, it's also very good is you could have your own little band, like a one-man band with these machines. You know what I mean?
You can have your own little band with these machines. And this was Bob Dylan being interviewed way back in 1986 about the current state of music. But it could just as well have been yesterday, because computers are involved in all the music being created today. Computers are helping writing the music we hear today. But luckily, being a musician myself, we still need people to play the music to get that soul and feeling out of it. And personally, I hope it stays that way. But there are so many things you can do with music, and the tools are ready. And even if you don't know how to create music, there are so many good tools out there that just about anyone can become a musician using computers. And you yourself can be part of computer music history. Thank you, and have a nice NDC party wherever it's happening, online. Whenever I get home, I'll have a drink with you. Thanks for seeing this talk. This has been High Scores, a brief history of computer music. We've been through lots of music, so I'll just leave you with this little text if there's anything that you would like to make a little note of. Thank you, and have a great reminder of the NDC.
Hello, and welcome to the 7 Commandments of the Effective Legacy Code Maintainer. My name is Dror Helper. Before we start, a few words about myself. I'm a consultant and software developer. I've been developing software for more than a decade, and I specialize in helping teams write better code. From time to time, I get called to help with projects that derailed a bit. Hello, or got to a point
to the
that they
7
are
Commandments
stuck
of the Effective
and can no
Legacy Code
longer be
Maintainer.
maintained
My name
or developed. Usually, I teach test-driven development, unit testing, clean code, and other practices that help developers do a better job. I'm also a Pluralsight author. I have several courses on Pluralsight, 2 of which on unit testing in C++ and 1 on AWS Lambda. I have a blog at helpercode.com and Twitter handle at thehelper where you can reach me. I want to talk about why we hate legacy code. And we do hate legacy code. And there are several reasons. Everybody got this bad feeling in the pit of their stomach when they need to write new functionality or even maintain legacy code, and not without any reason. Basically, we hate legacy code because it was written in the past, a while ago, usually using obsolete technologies, tools, and practices, and it's a pain to maintain it. Nobody wants to use all the things from the past. All of us want to work with the latest and greatest. And on top of that, working with those old technologies means that usually it's a pain to change things. And we need to follow certain practices or even write code that we don't really like. Now, also with legacy code, it's very easy to break stuff. Whatever we change, we have the feeling that we might break some existing functionality, and that causes us to change less. We even get to a point with some code bases in which we have no clue what might break in any change we make. And so it's very hard to work this way. It's like stepping through a minefield. In any moment, you might break something or something will stop working, and then you will try to understand what happened and how to fix it, and it's not a good place to be. And thus nobody knows how that legacy code works. It was written a while ago and people have no clue. No one knows what certain functionality, how it will behave when you try to change it or tweak it, or how it affects other parts of the system. Some of the time you don't even show what the requirement were when that code was written. All those things basically cause us a lot of pain when maintaining legacy code, and no one really likes to do that. Now, when you start to work with legacy code, there are certain guidelines or rules that I found to be helpful in order to reduce the amount of pain or completely eliminate it. And the first thing is do no harm. Do no harm, first do no harm, was coined by a known legacy code maintainer from ancient Greece called Hippocrates. He said, we practice 2 things when dealing with diseases, either help or do not harm the patient. Some people think that's part of the Hippocratic oath. Not sure about that. At least I couldn't find it, but I did find it in Epidemics Book 1. And maintaining the human body and legacy code is very similar. Someone else created it, and now we have a problem, and we want to make sure that we don't break anything when we try to solve that problem, basically. And that's for a good reason, because legacy code has 2 things going for it. First, if you change something and break it, you'll probably be left over the weekend trying to fix whatever you broke or until the middle of the night. And all of us like to go back home at some point. All of us have hobbies and families that we want to meet from time to time. So we try not to change or at least not break anything with legacy code. But the real reason we don't want to break anything is because of one single truth. It has users. Those users really care about your code working. They use it probably daily or at least at some point to do their job. and they wanted to continue working in exactly the same way. Those users are the only reason you're maintaining this piece of code, because if there weren't no users, if this particular part of the system wouldn't generate any revenues or wouldn't be beneficial to anyone, you probably wouldn't be trying to fix it or add new features. So those users are someone you care about. This piece of code is very important to someone, so you don't want to break it. So you want to make sure that you keep everything working the same way, or at least the functionality that is still there. Keep working the same way without breaking it. That's not an easy task to do. What usually happens when developers need to maintain such code and are afraid to change anything, they try to make small changes, not change too much, don't rock the ship. And you don't want to do that. Either you write very small changes or you write ad hoc changes, you debug the code, get to a certain point, you see that it might solve your problem, you write as little code as you can, and then you close that file and run away. But unfortunately, that practice, at least in my experience, will cause the code just to be less maintainable. The next change will be even harder, and after a week, a month, a year, it will be impossible to change anything in your code, so we don't want to do that. In the good book, Working Effectively with Legacy Code, written by Michael Feathers, which you should read, still relevant, he said that we need to mitigate the risk and we have to ask 3 questions. Now, answering those 3 questions is not simple, but they should be in the back of our head when we maintain legacy code. Those questions are, what changes do we have to make? And it's not just what code to write, it's about the existing functionality and how we want to transform it to the new functionality. What does that involve? Which objects, classes, functions, values are affected by whatever change we make. And we need to map those. Second, we need to answer, how do we know that we've finished working and we fixed the bug or added new functionality? How do we know that we made the changes and they are working? Do we debug the code? Do we run a test suite if we have one? Do we give some tester or product manager the ability to check our work? We need to define those. And finally, how do we know that we haven't broken anything? And unless we can answer those 3 questions, it's impossible to change code with confidence. Now, there's more to it than that. That's just outlining what we need to do. But there are quite a few things we need to do in order to be able to answer those questions. The first one is we need to make sure that this piece of code runs on our machine, or at least in some controlled environment. Because I've been to projects in which only one machine could debug and deploy, create an installer for a specific piece of code. Only Jim's machine can run that piece of code. That's a problem. You don't want that. You want that code to run on any machine, even if it means somehow creating a virtual machine out of Jim machines so we can run it in every developer machine, or at least understand the problems that cause it not to run on my machine. Is it an environment that I'm missing? Some third-party library I need to install? Maybe configuration, something here I need to configure and fix in order to run it on my machine. And I need to be able to do the following 3. Otherwise, there's no point in continuing. Now, we don't live in a perfect world, and I've been in projects in which people couldn't compile the code, but it's almost impossible to change code you can't compile. It sounds crazy, but I've been working with legacy systems for a while now, and I've seen pieces of code that developers don't even compile because they need a special tool, and that tool will only run on the build server, and that server, it will take it between 15 and 20 minutes to run. That's a problem. That's something we need to think about how to change, because I want to be able to compile the code. I need to be able to run the code on my machine. And I need to understand what it means, and hopefully I'll manage to do that. And finally, deploy. I need to know what it means to take this code I just wrote and give it to my customers or pass it along to the next point of the pipeline to testers or staging environment, whatever it means in this specific project. And the reason I want to do those is in order to be able to debug the code. Without debugging the code, it's almost impossible to know what works and what doesn't work. And without debugging the code, and it will be impossible to test it, even manually. If I can't run the code, I can test it, obviously. And the tools I'm using won't be able to help me refactor the code, so I won't be able to improve it. And I probably wouldn't be able to run most analysis tools, which I do want to. Most of them will help me do a better job. And without all those, it's impossible to move the code forward. Without all those, all I'm left out with is change whatever I think is working, send it over and hope no one will find a bug and call me in the middle of the night. Or the customer accidentally get a bug in his production system. So I have to make sure I can run the code. Once I have it running, then I'm ready to go to the next step, which is understand the code before you change it. Also sounds very trivial, but I can't count the times in which I saw people going and changing stuff and adding features and moving code around without actually knowing what goes there. And you need to be able to understand what the code does. And it's not easy. It's not simple understanding what a specific piece of code does. Because it's legacy code, means that even if you have any documentation, it will probably be obsolete by this time because things have changed. Maybe it was true when the project began or when we finished shipping the first version, but then things changed. Bugs were found, new features were added, integration team came in and changed a few things. So the documentation in most cases does not help me at all. The second thing is that I don't really know who to ask. The people who wrote the code probably is not around anymore. Some of them moved to other projects. Some of them left the company. It's very hard to find someone with an old enough code base to understand exactly what happens there. And if you do find this person, keep him. You'll have someone to ask. But most of the time, even if you find the person who wrote the code, it doesn't remember. And if it does remember, things have changed since he wrote the code. Other people went in, added new code, moved things around, fixed a bug, maybe did a few stuff, a few changes along the way, and he will look at the code and say, I don't remember doing that. And it might be his memory, and it might be the fact that things changed afterwards. The third thing is that that code grew over time. Things were added along the way. Small methods become huge methods. More parameters were shoved in. New functionality was added. And things have grown since that project was shipped or since we start working on it. And finally, probably by different people. So there's no one person to ask. So what can you do if you want to understand a piece of code that was just given? And I've been in this situation. I've came to companies and they gave me a huge method or a piece of functionality. They told me roughly what they think it does. Said, well, let's see if we can improve it. And then what you do? Well, first of all, ask around. Start asking people. Maybe you'll end up finding someone who knows everything, at least about what that code's supposed to do. In some companies, there's this guy or girl that knows everything there's know about that project. And if you'll find him or her, then you're lucky. You just saved yourself a lot of time. You do want to read the documentation. As obsolete as it is, at least you get the original intent. You know what the code was supposed to do. Don't spend a lot of time on it, but at least find whatever you can. Maybe someone drew a diagram, maybe someone wrote the requirements. Just check it out. It might help you. Another thing that helps me a lot is refactoring. When I go into a huge method or a method that I can't understand, I start playing around. I'm doing a small refactoring that I can safely do in existing code. When I pair program with another developer, I usually tell him, we are going to change the code a bit, don't worry about it. If you don't like the end result, we'll revert everything, we'll undo all the changes. But first I need to understand what goes there. I'm not trying to improve the code at this point, just to understand it. I'll throw a bunch of code into a method, try to give it a good name. I'll change variable names, ask someone what this variable does, or go back and find out what was the idea behind this variable, change its name so I'll be able to understand the code better. Now remember I told you, you have to be able to read the code. That's because at this point I want to debug it. I want to run the code on my machine, hopefully, if not on some remote machine, and go line by line and understand what values goes in, what values goes out. As the product manager, as someone who knows the client, how that code, that product is being used, and go through it and see how it affects the parts that you care about. Go line by line, document it, write it down, because the next step will be try to draw a diagram or a code map that shows you the flow, the important stuff. Doesn't need to be a formal UML diagram. Just a bunch of squares with arrows between them will be enough at this point. In fact, I've done this several times, and at least 2 times, the customer was so happy with the end result. In the first one, it became part of the project documentation because no one documented the core functionality of their application. And once I did, they were able to take it on to other teams. The other time, I wrote a nice diagram showing which method calls which method and which class, and roughly the idea of what that method does. Went through it with the customer. It was 3 pages long, my drawing. I did it with a PowerPoint or something like that, or Visio. And then the client went with me and said, well, I can see that step 3, 7, and 15 does exactly the same thing. We can probably eliminate them. And step 4 will never happen. And you gain a lot of insights about what the code does, which will help you not break it. Because you need to understand what exactly the code does in order to keep it working the same way. Now, there are several tools that will help you along the way. And one of them, which I use always when dealing with .NET code, is NDepend. NDepend, dependency graph, will, if you can compile the code on your machine, you can create a bunch of matrices, and the dependency graph is just the beginning, and you can immediately see how the different objects relate to one another, and you can find a bunch of problems and ideas and jump between that and the code easily. It's very fluent, it's very easy to use. In the end of this talk, I'll give you a coupon code if you would like to purchase it, but you can try it out for 30 days, decide for yourself. That's a very nice tool to use. Another one is ReSharper, which has an architecture graph. Not sure if all ReSharper users know that. And same for IntelliJ and other tools. It will draw the relation between the assemblies. So at least you know which uses what, and you can focus on the ones that you care about, as you see what I did. So I'll be able to understand that if I make a change in services, it affects web framework and exchange and whatever in a project I never saw before. And all those things will help me gain understanding. Now, the other thing I said is that I use refactoring in order to gain readability, because the number one offender with legacy code, in my experience, is huge methods that stretch as far as the eye can see. Those are impossible to read and impossible to understand. And you don't need to really work hard to get there. Just make sure that you only make small changes all the time and you end up with the huge methods, which usually happen with such code. And the easy part is just look for if statements or comments in the code and just mark a bunch of code and use your ID of choice in order to extract that to a new method. And all modern IDs will give you that functionality, and most old IDs as well. Eclipse, IntelliJ, Visual Studio Code, Visual Studio with or without ReSharper will extract blocks into methods, give them good names, and you'll be able to see the functionality. And don't try to fix everything at this point. Even if you see duplicate code, if you think there's a better way to write this code, at this point you don't want to break anything, so don't make any huge changes. Just throw things inside methods, and you'll be able to see the flow. For example, this is the Gilded Rose refactor in kata by Emily Bach. And this is the main method. And as you can see, it's not unreadable, but it's hard to understand how the different for, if, else, and so on relate to one another. This is also known as the arrowhead pattern because it looks like this when you have a lot of nested if statements. And you can really fix this code easily using your favorite ID, because all you have to do is mark a bunch of if statements and throw them inside a method. And looking on this code, roughly we can see that we're using a for loop, but in fact we're always taking the same item, the item in this index, so we can change it to for each. Also, the first line up here, we can tell that it's asking if something is not this and not this and not that. So probably I can inverse the if statement, not understand what exactly is done here. And same goes for here. And I can see blocks. There's one block here, another block in the else statement that I can probably break into this part and whatever goes below. That method stretches for quite a long time. You need a very big screen to see it if you can manage, or you can just extract things into methods and it will look like this. And now I can understand what it does. If the name is not whatever Brie or backstage passes, then decrease item quality. Else, handle special items, whatever that means. If the item name is not Suphoras and of Regneros, then you need to reduce the selling price. And if it's below 0, item expiry date has just passed. Now we can see the flow. Now some people don't care for this kind of refactoring. They say, okay, now I need to dig in and dig out of the method to understand what it does. Well, first of all, that's a safe refactoring. That's just for readability. You don't like it, revert, undo. But in fact, this is basically a way to see the actual code flow. People tend to say something I don't really understand about the code telling a story. But if you want to use this specific allegory, if the code tells a story, it needs to be precise. If you go to your friend on Monday morning, ask him, what did you do in the weekend? You don't want to hear, I woke up at 10:30 and then I went to brush my teeth. I sat on the couch for 15 minutes and then I ate breakfast, went all the way to the door, opened the door, went out, locked the door, went all the way to my car, started my car, and so on and so on. Obviously, this is too much information. You want to be able to ask him, what did you do in the weekend? And he will say, I've been to the beach. And then you can ask him, oh, that's nice. What did you do at the beach? When did you arrive at the beach? That's like going inside a method. And he will say, I arrived at 10:30 because I woke up late, or I like to sleep late. And we can have a conversation that both of us understand. No one falls asleep in the middle of it. Same for your code. Every method should be one layer. You don't want to overexpose everything. And once you throw things inside method easily this way, and you can do it with your refactoring tool of choice, you don't break anything. Well, in some languages you might, but in most you don't, and all tools know how to properly refactor into a method. And you'll be able to understand what it does. Now we can understand this code and we can change it, and we need to change it. It doesn't work in no way that I want it to work, and there's a lot of duplication, but at least now I can see parts in boxes that are easily to understand. So once I understand the code, what do I know? What do I need to do? Well, now I need to change it. We finally got to the important part. We need to change it with confidence. We need to be able to know that we haven't broken anything and that we managed to implement whatever they ask us to do. And for that, you need automated test. There's no two ways about it. it is impossible to make sure that you haven't broken anything unless you have tests that run continuously, either on all commits or at least once a day, and make sure that whatever they are testing is still working. On top of that, tests give you a quick feedback. You finish implementing something, fixing a bug, you run all the tests, you see that you haven't broken anything, at least to the best of your knowledge. If you get a bug, add more tests. But at least you're in a better place than having no tests at all. Also, once you have tests in place, then the next time you'll need to change something, you don't need to run the whole application. I've been in projects in which running the application can take between 10 to 35 minutes. I don't want to run that application every time make a change. I want to run just the test and debug it and see that everything is fine. So I want automated tests in place. But unfortunately, it's not always easy because we are talking about legacy code, obsolete tools, obsolete methodologies, probably to begin with, without a lot of tests on it. And then we have a dilemma. The legacy code dilemma, as it was called in the Working Effectively with Legacy Code book. In order to change the code, we need to add tests. In order to change the code without breaking anything, we need tests, unit tests, integration tests, component tests, whatever. But for adding tests, usually, to begin with, we need to change the code. Now we can go in circles all the time, or because we can't do anything and we're stuck essentially in this point. Now, one thing we can do is write integration tests, scenario tests, end-to-end tests, whatever scope we can, in order to make sure that at least some of the functionality behaves properly. It might take a while, and those tests they might be fragile at this point, but I want them to run in the duration of the time it takes me to get to writing unit tests. So I'll write those tests, those end-to-end integration tests, whatever scope I can. Usually it's easier because taking a huge pile of code, testing it from end to end is easier than trying to understand the different parts inside the code in order to write unit tests. And you gain some insight by writing tests, even end-to-end tests, and then you refactor your code so you can write unit tests. And then you get to decide if you want to delete those integration tests or keep them in place, depending on how fragile they are. If they'll break all the time, throw them away. If not, that's a good thing to have. And writing unit tests is possible. Another thing I can do is what I call safe refactoring. Safe refactoring is basically a bunch of small things I can do that doesn't break the code. Extracting to a method, renaming stuff, adding things that doesn't change the existing functionality. We'll get to that. Extracting an interface from a class. All those things won't change what the code does, but it will help you write unit tests. Because the difference between end-to-end or integration tests and unit tests is that you have dependencies in your code that you don't want to run when you run unit tests. You want to run in an isolated fashion, divided and from your actual services or file or database, because those things will cause a noise. You don't want your test to fail because the service is not running. You don't want it to fail because the database doesn't have permissions or the correct values there. But in order to change those, you first need to understand them, which hopefully you know by now, because you read the code, debugged it, and added some end-to-end tests. And now you want to replace all of those dependencies with fake objects or mock objects, depending on how you like to call those. And once you do have those fake objects, which are usually done easily by using a mocking framework that inherit the original object and override all of the methods, so they do absolutely nothing unless I tell them to do something else in the tests. Now, if you never worked with fake objects, with mock objects, I suggest you find some good tutorials online or in your unit testing framework or your in a code programming language of choice. You need those. You can't do without. But once I have those fake objects, I need to be able to go in and pull the real object out and put in the fake object. And in order to do that, I need to open parts of my code, so I'll be able to do that. In some frameworks it's easier, in some frameworks it's harder, but basically it is known as dependency injection. Now, a lot of modern programming use dependency injection, but unfortunately not everybody works on modern code bases. So we need to find a way to do dependency injection when it was not written there to begin with. And then you need to do something. Usually it means either extracting interfaces for existing class, because people used to program against base classes in the past and not pass them through the constructor. You can create another constructor. This is the #1 way to create dependency injection. You have a constructor that does absolutely without any parameters, and inside a bunch of initialization, create another constructor that gets all those objects from the outside, just use it in your tests. That will be good enough to begin with. If you have absolutely no choice, you can create accessors and delegators. Those are special methods that you use for tests. And unfortunately, those things will cause the code to look not as neat, and people will accidentally use them in production. You don't want that, but if you have no choice at this point, do whatever it takes. You can even pass functionality as delegates, methods, lambdas, whatever, in order to encapsulate it and change it in your code. Now remember that when working in legacy code, it's very similar to roadside construction. If you try to take a roundabout and replace it with a different kind of intersection, in the beginning, there will be holes in the road. In the beginning, there will be traffic jams and people will be late to work. But slowly but surely, things will get fixed and will change to the way you want. So don't worry if you do a lot of small things that will help you better test the code, because they will go away after a while. But in the beginning, you need to open those bunch of holes in your code in order to replace dependencies. One of those patterns, there are quite a lot of patterns, is called extract and override. This is a pattern I only use if I have absolutely no other choice. Usually when someone did something bad in the constructor, most of the time it has to do something to do with the database. Extract and override says, I'm running the code, it crashes. It crashes because of some dependencies was initialized or ran, and I can't change it with dependency injection. What I'll do, I'll take that piece of code, I'll extract it to a method, a virtual protected method. I create a subclass in my test that inherit that class that has this piece of code in, and override them offending method. And then I can test it. I'll show you what I mean. Here we have the trip service kata. The trip service kata basically is another nice coding kata that has to do with legacy code. And as we can see, I have a user session here. This is a class, it's a singleton. We can tell by the private constructor and by a static method called getInstance. It's a bit of a naive implementation, and it has two methods. And both of them will throw an exception that is intended to show us that the database is not there. So we're not allowed to call those methods in our unit tests. But we want to test another method that uses this singleton. And unfortunately, it was used in a very naive way. I have a method I want to test called getTripsByUser, and it uses that user service here. Now, I have several things I can do with this singleton class. The first of which, I can go inside that class back, change the constructor to protected, and add another protected set instance that receive user session. and set a user session equal new instance. And that, and obviously need to be static method. Now now, obviously, on top of the compilation problem, there are ways to do that, but they are not nice. I just broke in the singleton, and someone might use that against me. Another more elegant solution is to take this class, because on top of the singleton part, there are actual methods here, and do a quick refactoring. And those are a bunch of refactoring I can do with ReSharper, but all of them are possible with Visual Studio, and of course, and I saw them in Eclipse and IntelliJ, where I work quite a lot, and you can extract a new interface. Now I'll extract a new user session and implement and define those two methods I need. And now I have an interface that I can easily fake because it has nothing to do with the singleton. And then I'll go back to the code, this piece of code, and I can add I user session like so, and use that. And the singleton call will go to whoever calls this method. Now I can fake that easily in my tests, and now I can test this piece of code. Now, it's a good thing to push all your singletons as high as you can to the beginning of whoever initialized all the system. You can't always do that, but what I did basically means that whoever uses the singleton in other places in the code will continue functioning the same way, just this method was changed. Now I need to fix only this method, which basically is finding all the places in which that method was called and just pass the right parameters. Now it could be a few dozen places. Now in this case, there's another solution, that's extract and override, which I told you is the last resort. So basically what extract and override means is I'll take this line like so and use another extract method. Yes. And I could get logged user. And going back, it's not static. It's turn it into protected, virtual, get logged user. Now in my tests, I'll override this class, the one I'm trying to test. I'll inherit it in get trips by user for trip service for tests. And in trip service for tests, I will override that method that causes me a bit of grief. And whatever is returned from a user session, then I'll return my own user, depending on what I need to do in this specific test. So this is basically extract and override. Simple as that. Now, obviously, the class is not better for it. But as I said, this is something we do in order to test it right now. And hopefully, when we do a bunch of those things, we'll change the code quite a bit. And in the end, we'll end up with something that we can either move to another dependency injection framework, IOC container, or we can find other ways to do that. But at this point, I can at least test the functionality in this class until I get at least to this, which is static methods. But I can do the same tricks I just showed you with that static method as well. Now, that's not the only pattern. As I said, you can add dependency injection, constructor injection, method injection, like I showed you, even put a setup property. All of those are valid, and you need to be pragmatic about it. Do whatever works for you. Find ways to test your code. Then find ways to make it better, not the other way around. Because then you'll make sure that your code doesn't break. Now, the fifth commandment is clean up before you leave. Well, it was coined by Uncle Bob, Robert Martin, in the book Clean Code. Another good book to read, it's not big. And he says, always leave the code you read it in a little better than you found it. Also known as the Boy Scout rule, because Boy Scouts leave the campsite cleaner than they found it. Don't be that guy that says, it was like this when I got here. I had a friend, a very good, talented developer, and I did a code review, and I asked him, why didn't you write any unit tests? He said, because that class didn't have any unit tests to begin with. That's not a good excuse. You always want to improve it. And improving the code is not hard. Do things that makes you feel better. If it hurts, change it. This piece of code has hurt us in the past. It's unreadable. Maybe it has some bugs in. In one team, we had the rule of 3. If a specific piece of code annoys us 3 times or more, we will find ways to improve it and change it. Some changes are easier than others. Again, using safe refactoring, or once you have unit tests, you can do bigger and better kind of changes. You can easily make the code look better. And you can do that even by a simple rename. Just renaming a variable to say whatever it does. Another thing you want to do, delete that code. You know those commented out pieces of code? Remove them. It's a mental load to read through those pieces of code all the time. I hate that. Just delete those codes. It won't benefit you in any way whatsoever at this point because they're not even being compiled. You need to delete that code all the time because you have source control that keeps your code forever, and you don't need to keep it in your code. It has absolutely no purpose, and in 1 or 2 or 3 months time, it will be irrelevant in either way. You really want to keep it? Just save it in a document and put it somewhere. Don't keep your mess in the code. And the changes are tremendous. Those small changes, rename and delete that code, will improve your code. Doesn't matter what you do. Here another example from the refactoring kata, written by the late Scott Allen, and very good code kata to perform. Usually do that when talking about refactoring because to begin with, that code is unreadable. You have no idea what this method does. Take a while, look at it. There's a find method, returns f, yet an ft, and then it runs on p, and with new f, it has birth date, there's a name there, and a bunch of things, and when walking through this code, you understand a bunch of things about all those names, and you can rename them. Just use rename in your IDE, in this case Visual Studio, you end up with something much better like this. This is the same piece of code. I haven't changed anything, and I can extract methods and do other things here, but for now, it's easy to understand. I'm running on persons, they have a birth date, and I'm trying to see the age difference between those persons in order to get the best pair, whatever that means. And the code suddenly is readable. All I did is 5 renaming. I renamed the name for person, query to query by. It was F for pair, and FT for query by, and P for person, and everything is slightly better. It can be further improved and should be further improved, but at least it's not as painful reading it all the time. Even if you have an idea what those names means before, you always need to think a minute to think. You have like this hash table in your head says, okay, FT is the query, and F is a pair of 2 persons, and P is a person, and that's a fraction of a second or 10 seconds it takes you to remember that. It's painful, but the fun fact is that you only notice it was painful when it stopped being painful after you do a rename. Always clean your code. Don't overdo it, but make sure that you leave the code in a better shape than you found it. Now, doing all that things is a bit time consuming, but you have to remember something when working with legacy code, because the legacy code can take quite a while to fix properly, or so-called properly. Don't forget you're on the clock. maybe the first day no one will bother you, but after a day or two, your manager will come and ask you, what are you working on and why you are not done yet? You need to remember that everything takes time. You need to estimate what can you do in a day, a week, a month, and how much time people will give you to do it. For example, in a project I worked for a while ago, we had the code of the core business of our company. It was called the switch process. And that switch process was written over time. And it had a bunch of Boolean values and bunch of events. And it was very hard to see the flow. It was very hard to understand what happens there. And after half a year of working on it, we understood that there are better patterns that will make the code better and easy to understand, debug, and make sure no bugs are hidden there. Because that was crucial to the company. And my friend got the job of refactoring that code. But before that, my manager asked him, how much time will it take? And he said, well, 2 weeks. The manager thought about it for a while and said, well, right now we don't have 2 weeks. We'll do that next time when we have 2 weeks. I'll tell you a secret. We never did it. We never did it because you'll never have enough time. You have to estimate not how much it will take, but how much will be given for you to do it. And if it takes 2 weeks, don't say 2 weeks. Just tell your manager, well, after there we'll be there, after 2 days we'll be there, after a week we'll be all the way over here. Because you have to break things to smaller tasks and make sure that he knows what he commits for. And each such task will move you closer and closer to whatever you're trying to achieve. And every one of them will improve whatever you're working on. And you'll end up with doing the 2 weeks you wanted, but one day at a time. So always remember, things take time, and usually we don't have that time. So do small changes. On top of small changes, try not to break the system for long periods of time. In the beginning, when I worked on legacy code, I used to find good ideas and I wanted to change this pattern and change the way the code work. And I would change a bunch of things and the code would stop compiling. And after 2 days, 3 days, I'll get it to compile again and debug it, run a test, and find out that I made a mistake. It's not the right thing I was supposed to do. So I'll revert everything and go back, and that's not a good idea. You want to keep those cycles as small as possible. You want to break everything you do into small tasks. In the end of each task, you want to commit. To commit your code. If you're working with source control such as Git, you can locally commit, just so that if you find a mistake, you can revert to the last save point you have. And once you do that, remember to merge when possible. Don't wait too long. Whenever all the test passes, nothing broke, and you improve something, either you wrote new functionality or something was improved, you don't have to finish the task. Push it, merge it back. So the code, other people code won't progress without you. Otherwise, you'll end up with a lot of merge fixes and the code moved around and now you have a problem. And also it shows progress and enable you to find problems sooner. So you have to make sure that the system keep on working and as soon as possible, merge back. If you work with feature branches, then finish the feature, but keep on merging from the main branch all the time to make sure that your code is in sync with whatever goes there. And the last thing you need to do is to learn and improve. Learn and improve is a big part of maintaining legacy code. In the beginning, we know absolutely nothing, and as the time go by, we learn quite a lot. And we can find things that waste most of our time, and then we find stuff that we can improve. How long does the compilation take? Is it too long? Well, let's reduce it. Let's split things into different module assemblies, whatever it's called in your language, programming language of choice. How much time it takes to run the test? Too long? Okay, let's think how to do that. Maybe we need to run them only at night. Maybe we need to split them to fast test and slow test. Do I wait for the application to start a few times a day? Let's make sure I don't, either by making the startup time less and less, or by running only parts of the application either in a test harness or in some other way. Find a way to make everything take less time, and you'll find places to improve. You can add automation, a build server. Maybe a deployment is done manually. It takes 3 days. Reduce it to 1 day by using automation. Reduce it to 1 hour, maybe. Find new tools to help you do your job better. Nothing fun than using new tools, either to analyze the code for you or run it better and upgrade libraries when you can. If there's no point in using an old .NET version, maybe move to the new one. You'll get new language construct that enable you to express what you want to do. In some projects, you're not allowed to, but in most, small upgrades are possible, and slowly but surely, you'll improve everything and connect measurement tools and metric tools and analysis tools to your build system and use them on your machine. Again, and depend, SonarCube, all of those can be added either by you or if you have a DevOps team, they'll love when you give them nice ideas that will make them and you look better. It will show progress and then the rest of the team will notice. Maybe the rest of the company will notice. And that's a big important thing about learning and improving because you need to teach others. You want other people to help you maintaining the code and improve. You need to have others read your code. Once they read your code, they understand your code, they see what you've done, and they'll do the same thing. How do you get people to read your code? They're obviously not in a reading session. Either pair a program with someone, or better yet, ask someone to code review you. When you get code review from someone, you learn a lot from him, but he learns quite a lot from you. I've learned how to do new stuff and test in different ways by doing code reviews to other talented developers. Get people to review your code, they'll see something they like, they'll use it in their code. Because basically you're probably not working alone on that piece of legacy code, what other people to follow the same practices that you found to be effective. And become a knowledge base for your company. If you're the only one that know how to maintain that code, it's not good. Teach others, and people will come to ask you questions, and you gain some status. Maybe you'll be promoted at some point, and the more you know, the more you'll become that person who knows something about this. And you'll gain insight into your company business because again, you're working in code that your company, that is crucial to your company in some way. It has customers maybe, or either internal or external customers. You understand what your company does better than just writing code. That code is the sum knowledge of everyone who worked on it to solve some problem from someone else, which is probably how your company is making money. So you become someone who actually understand more than just the code. You understand the company. If you want to become a product owner, product manager perhaps, that's a good way to go. And you will learn practices that will help you in the next project. It will make it awesome. You'll see what happened, what worked, what didn't work, what you should or shouldn't do. And in the next project, you'll probably don't make the same mistakes and you'll probably be able to improve. In one company I worked for, it was a huge company. Every developer went through development, then deployment of the project, then supporting the customer. And after a year or two, went back to write the next latest and greatest project because that was a good way to teach those developers what the customer actually need and how to write proper code and what not to do. The mistakes that was done in the past, we don't need to repeat them. We need to find new mistakes to do. And you can harness your team to the effort because people will see you doing things that work. They will want to do the same thing. They will help you in doing the same thing. Teaching unit testing without writing with someone unit test is hard, but once people see it working for someone, they will try it as well. Same for code. They see you doing stuff that was impossible in the past, and they'll want to do it as well. And then you get the ultimate prize for being successful in maintaining legacy code. You'll get to do it once again. You get to do it once again because the reward for doing a good job is getting more work to do. But that's a good thing because all of us like to write code. And also, you'll notice something after a few weeks, a few months, you get to make bigger and bigger changes. First of all, you have more confidence in your code, but more importantly, Your manager, your team will have more confidence in you. You were just successful doing something, so you get to do bigger and bigger things. You get more interesting, more important things to do as the time progressed. When I was a new developer in a team and I wanted to change one of the crucial tools there, manager told me that won't happen. After half a year, he was more open to the idea because I showed him I know what I'm doing. I was successful. I had those small wins that grew and grew and grew until I could change something very crucial to the system and improve it because my manager trusted me. So not only you get to do it again, you get to do it bigger and better. And that's the end of it. Then you do it again and again and again until at some point you'll probably be moved to another project or maybe another position. Hopefully not leave the company, but that's up to you. Maybe become a consultant and teach about legacy code because you'll gain a lot of insight by doing that. Because legacy code doesn't need to be painful. It doesn't be something that people are afraid of. If you do those practices, you'll manage to gain control over your code and improve it to a point in which it is no longer legacy code. It's something that is maintained and grown over time. So, to summarize, we talked about 7 commandments, effective legacy code maintainer. The first of which, do no harm. You are not allowed to break anything. Then make it work. Run on your machine. Otherwise, don't continue. Then understand before you change. You need to read the code, know what it does in order that you can maintain that behavior and know what you need to change with confidence. Confidence equal automated tests, integration tests, scenario tests, unit tests, especially unit tests. And then clean up before you leave and improve the code even further. Remember that you're on the clock and learn and improve. Thank you for listening to my talk. If you have any questions, I can take a few questions now. We have a few minutes. You can write them down or even ask them. And if not, I'll try to be available in Slack, and you can always ping me in Twitter. Well, thank you for listening.